Welcome to this lecture on designing a virtual reality. Are you confused? Well, I just thought, what a funny way to kick off this lecture, being in virtual reality. In fact, I was just looking at a virtual reality desk, so the Oculus kind of like area that you see when you start, and wanted to play a trick on you here. No, this week is going to be quite cool. You're going to learn about a lot of the basics when it comes to virtual reality design. I'm going to share a few techniques. I'm actually quite excited. So the way I've structured it is like, this is the intro to virtual reality, but development. I'll just assume you know about the concepts and you know about the technologies. If you feel like you have some refreshing to do, please look at my other MOOC. The first one is part of the WebXR MOOC. The first course really provides this foundation. In-depth review of VR and AR, both the concepts and the technology. So, designing a virtual reality. And as I said initially in week one, we are going to have two case studies throughout this entire MOOC, contributed by two of my students, Kara and Shweta. And they are obviously great students, but also they contributed really cool case studies for us. This one that we're going to focus on this week is a zoo. It's a virtual reality version of, well, it is modeled in some extent after the Detroit Zoo, but I have to be very careful here. The Detroit Zoo, this is not affiliated with them. The Detroit Zoo was not a client of ours. There's a different story behind it. I was doing an online office hour on Twitch as part of my residential teaching, and I felt like, hey, I should really design a virtual reality, and I should probably model it after some reality, even though I'm not a strong believer that we need to copy the real world. But I wanted to have a zoo. And I started out with the basic layout and the animals. And now, then later, at some stage I thought, hey, this would be a really cool case study for us for the MOOC. So I asked Kara Daly, my student who helped me, who was a course assistant, a course design assistant as part of this MOOC and in the background, but we are going to interview her as well. She helped us create this really cool case study. In fact, she sat down and implemented all of this. So we're actually going to learn about a number of things. We're going to focus a lot on environmental design, just in this lecture. But later we're also going to learn how to travel in virtual reality. You see elements of this already in some of the videos I show. We're going to learn about object manipulation. So traveling in a zoo, you can imagine, right? You want to see all the animals, so you go to different areas in a zoo. That makes sense. So then we were thinking, what kind of manipulation could we do? And so we have this petting and feeding area. It's actually quite a scary area because we have like really big gorillas there. So you want to be careful, not so much petting and more feeding, and probably more about far manipulation. That's a term that I introduced later, than anything coming too close to them. I want to be also again very careful here. We're going to look at this. I do say Detroit Zoo from time to time because, again, this is what it was modeled after. It just started in an office hour, as I said. This is not approved or somehow affiliated with the Detroit Zoo. In fact, the Detroit Zoo, we talked to them. They have very high values, and a petting and feeding area is actually a no-go. Now, I thought, that is very important for us to know. I totally understand. Animal welfare, they're making a really good case there. It would be very disruptive to the animals, and it would be actually not good. But we can do this in virtual reality without harming anybody. So here is a screenshot of what you're going to see in a second. I'm going to actually walk through different stages of design. In the end, it became a night safari. But it didn't start out as a night safari. It looked really quite sad. This is what I produced as part of my office hour. So this is what I had. And I was basically just creating a map. Already had a little bit of interaction in there, so you could use your controllers and you could teleport around. It's relatively easy to do. But then Kara came in, and Kara then actually turned it into something beautiful. You can see the basic elements that I had, they're still there, but now we have animals in there, lots of animals actually. Everything here is based on free, publicly available models, so we didn't actually model anything in here. We created a menu so we can actually navigate in this world. This is the part where we learn more about object selection and travel, navigation and menus, and then object selection is here, and manipulation. So we have this, as I say, feeding area. We have monster bananas that you can give to really big monkeys. Yum, 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 yum is what I say here. I'm going to share this case study with you as well. If you want to, I'm going to do a walkthrough. I'm going to take you on a 10-minute safari. You can listen to me and learn a little bit more about the ideas behind this project. And it's a cool case study. I'm so glad we have it. So I'm just going to say thanks again to Kara. We're going to talk to her later as well. This is a beautiful aviary, so we have really nice birds here and really quite cool areas to explore. And putting it together with this night safari, which is something I really insisted on, inspired from a few trips to zoos. Well, I'm a big fan. And so the night safari is also that idea of the night safari. So turning this into a torchlight and also having a laser come out of it. That was actually pretty good for our case study because you learn more about light and this idea of really giving agency to users, and it adds to this explorative nature of virtual reality. And even though everything in there, you probably now say, this, Michael, if this is it, if this is your zoo, then that's a little disappointing. Okay, then maybe you have very high standards. Maybe you're used to going to the movies and watching Disney movies. So keep in mind, that was not the goal here. This is not designed for aesthetics, although I do think it looks quite pleasing. It's not high quality, high polygon count. It's actually all free models. But I suspect that when you get started in this space, this is how you will work. You won't be this Disney artist. Maybe if you are, that's cool for you. I'm jealous. But the majority of us are just, throwing things together, and that we can find, we need this model and that model, and maybe we work with somebody who can model things for us. So remember what doing XR actually involves lecture I was talking about our Disney project. So I was just thinking back to that. If you don't know what I'm talking about, second course, week 1, check it out. All right, let's go and talk about what we're going to learn. So virtual reality content. Okay, so we're going to learn about a few things. What does it actually entail to create a virtual reality? So if you think about it in terms of just content, yeah, 3D models and animations, sure, we're going to put some 3D characters in our world. We're going to have a story that way. These 3D characters are actually the main ingredients, okay? They can be in the foreground and in the background. In fact, they can actually play a really cool role in the background just for atmosphere. Lights and shadows. Required for rendering, obviously. Well, I say obviously, but that's something we've touched on in the 3D lecture last week. So yes, we need light in order to see something in ambient light. And then we have directional light. And then we can have spotlights like we do for the torchlight here. Can give visual cues to users, very important. The environment, so really the terrain, or like whatever you walk on or what you see. And this environment, like trees, rocks, lots of things, really cool tools in Unity. But even A-Frame has an environment component that can be configured in many different interesting ways. So that's usually sufficient to create this kind of like presence in a virtual world. Physics are really important. Like if you want to model after the real world, where we have physics, at least on most planets that I've been to, which is actually just Earth. Make or break the VR experience. So if you don't get the physics right, if they are missing and users are expecting them to be there, not so believable. So that's really something to take into account. Spatial sound, so audio, 3D audio, whatever you may call it, spatialized sound. That's so more than stereo, okay? Really, truly spatialized sound would, let's say, if there were an object in between us right now, and then as that object goes, I was just saying you wouldn't hear me really anymore. That would make a difference, okay? So bringing an obstacle in here would modulate the sound. And if you're like in a big room, you would expect it to echo, for example. And if you're in a small, constrained room, you can make it feel very tight. So all these things coming together, don't forget about the sound, not just the visual. So it's actually key to immersion. VR experiences with sound are much more believable, and actually something is really missing. But initially when you start out and you're designing for able-bodied and you yourself are able-bodied, you probably predominantly design for the visual senses, but don't forget about audio. So menus and HUDs, really, they work actually differently in VR. So heads-up displays is something that really just makes sense in virtual reality and also in augmented reality. So we're going to learn about this as well as we go through these the content this week. So allow users to trigger functions, navigate, and customize the virtual reality experience. especially the menus. So another way to think about it, and these are also some things that we'll actually learn about, is virtual reality interactions. Okay, so we need to distinguish at the highest level between selection and manipulation. So on the selection side, very common is to have kind of like a virtual hand. So your controller, you can show the controller or an approximation of that physical controller, but we can also give you a hand model. It's very common. And now we actually have hand tracking, so it will almost look like a real hand, you know, like a hand, instead of a virtual copy of this. And the in-between solution has been that you show the controller, or you then replace it, like remember when we were entering virtual reality? Well, I'm not sure whether you've seen my first lecture really on VR concepts, but I was going in the Oculus lounge. I was going through the Oculus tutorial actually. And then due to the controller design and how the buttons are placed, we know roughly which finger is where. We can make these sensitive, which is what they did, and so we can detect where the fingers are. So we can actually render a hand model that does interesting pointing, thumbs up, or whatever kinds of interactions, even if we don't have hand tracking yet. But hand tracking is becoming more or less the standard. You can have a laser pointer, we're going to talk about that. We're going to talk about different kinds of manipulation or grasping to really change objects in the world. That's really exciting. It's a little bit more challenging, but it's possible. And then navigation or travel, so it can be gaze-based. So what I mean by that is you travel where you look. So we're going to learn about this in Half-Life Alyx. They actually really did this. Where you're looking is where you're walking. It's very interesting. But what I'm also thinking about is like, let's assume you're not rich, we don't have all this stuff here. Which is, I wouldn't have all this stuff if University of Michigan didn't give it to me. I would probably just have this. And many of us will just have, maybe not even the virtual reality headsets that I show from time to time, like the Oculus Rift or the Rift S or the Quest. Maybe many of us will just have this. And so gaze-based travel, so even just 3 degrees of freedom is something we can implement. And it's still a form of virtual reality. You can still have quite immersive experiences in there or in the Oculus Go, which has been discontinued, just like the Daydream. So no more 3DOV. Teleporting, so use the controller to activate the travel function. That's something you can do. And then obviously you can do menus. And we learn about menu designs. You can fix them, so anchor them in the world or attach them to the camera. They can follow. So there's a little bit of delay. It's like you moving your head and then it's coming, rather than you moving your head and it's attached to your gaze, so it's always there. I like this following more. So it's very common, for example, on the Oculus, not so much, but they actually have a fixed menu, at least in the latest version. Their OS changes all the time. Design patterns, design patterns, design patterns. On the HoloLens, we have this follow menu. And so some of these ideas and concepts really translate nicely between AR and VR. And then some of the things we talk about are really just unique to VR or AR. So we're going to do this case study. We're going to look at it step by step. Okay, so here when you're designing a virtual reality, one of the things I did was actually just put in an environment just to have a little bit of a feel for that. I actually enabled travel, so allowing teleportation. And then I was thinking in terms of zones. And so I was just planning out the map. And then gradually, Kara came in and she made it beautiful. Gave me some animals, played more with light. We added the menu. We're going to talk about this in more detail in the next lecture, focused on menus and navigation. So this menu then allowed us to navigate in this world, in addition to teleportation functions, so common travel functions. And then we also have built, as I said, into the zoo a feed the animals area. This is completely fictional, nothing that you can do in the Detroit Zoo that this was modeled after. And then we put the experience together and it actually looks really beautiful. So, I mean, from my perspective, as someone who is not a true 3D artist, I enjoy working with people who are really good at 3D artists. 3D art and 3D design, but I'm personally not. I'm more of a developer and engineer. So we're also going to learn about object placement. We have actually really important key terms here that we need to learn about. When you place things in the virtual world, we have basically at the highest level 4 different ways to do this. Okay, especially when we're using WebXR. Okay. So, and this is not just related to virtual reality. This is a little bit more, some of it doesn't make so much sense in virtual reality, so it's more like XR based. So, anyway, you can place things in the world. So the object actually exists within the 3D world. This is called diegetic. They are part of the story, okay? So they can be anchored in a fixed position, or just like somehow floating in the world and then following you. But they are like essentially in world rather than in screen space. So screen space means the menus would actually be floating. So the object is in 2D over the 3D scene. So it could be attached to your heads-up display, to the virtual camera. And this would be non-diegetic. It doesn't participate in the story. It's just visible to you. So in Half-Life, when we look at their menu, that is really a non-diegetic menu. It's really separate from the story. It's just there that you bring it up to configure the game, and that makes sense. Then we also have obviously options of putting objects in 2D on the web page. And so while you're thinking, hey, but this is not in virtual reality, well, on the web, when you're working with virtual reality on the web, you can always exit out of VR and enter VR. And you can actually have very interesting transitions between the 2D web and the 3D web, and then especially virtual reality. And so any kind of placement in the DOM or page means it's actually not visible in virtual reality. So it's actually separate. It's separate from the canvas that renders the 3D scene. So keep that in mind. If you're like working on a WebXR solution and using A-frame, put the stuff inside the A scene, not outside the A scene. And this is part of the honors track, so it's an invitation to come there. We're going to hack a little and understand this better. And then attached. So you could actually, it's a combination of the above, so you could have the object anchored within the user's gaze, controller, or hand. So it could be head gaze. You could even do eye gaze very soon. I mean, it's not that standard yet, but it is coming to VR devices as well as AR devices. We really deal with object positioning and sizing a lot. I think this is one of the key things. When you're transitioning from 3D, just plain 3D, from last week to this week, thinking about VR and just porting your scene and seeing it the first time in virtual reality, it's going to be cool, but it might actually be catastrophic because stuff might be just too big. So we really need to think about the position, the rotation, and the scale of our objects. And we really have to understand how these things are defined. A unit of 1 may translate, at least per default, depends on how on the resolution of your virtual reality. It can translate 1-to-1 to the real world. This is what we expect, at least in augmented reality. But we can usually scale the virtual world. And so that scale, then the world scale, determines the resolution. And so that's when things get messed up. But it allows us to overcome portions of that world. So it's interesting. In any case, the location of the object in absolute 3D coordinates, when I say position, this is what I mean. So think meters away from the camera's calibrated startup location. It's especially true in AR, but also in VR. Sometimes it's not really clear where the world starts. It has to do with what you do sometimes when you press the home button on the Oculus. Press the home button, like put forward, press the home button longer. It recenters everything this way. So this would be your starting location. And then the scene will be laid out in front of you this way. And if I go like this, then everything will be appearing this way. This would then be 0 degrees, not like 30 degrees from that previous example. So keep that in mind. Rotation, the angle of the object. So this is really when we're moving objects around the y-axis. So I'm going to give you this example. Moving objects around the y-axis would be this way, right? Okay. And then X and Z is a little bit more complicated to show. I'm not going to do that now. So just stick with Y for now. But this is something you've learned last week, and probably, I'm sure, we need a bit more time. Think in terms of degrees or radians, and radians is a little bit of a harder concept mathematically. It's used a lot internally, so maybe something you'll come across, especially when you move out of A-frame into 3JS. So it's essentially in degrees the difference from the model's orientation. And keep that in mind, it's going to be very important. Let's say you have a virtual reality model of Michael, and we put the pivot point here, and then you rotate me around X or something, then that would be where we rotate. If you put it at the bottom of my feet, then it's more like the whole body is like moving, like if it's here, okay? Pivot point here, pivot point here. You see the difference? So keep that in mind. If this doesn't make sense right now, then you haven't actually done anything in VR yet. This is really key when you start, especially in 3D in general, but especially in VR. Keep that in mind, especially when you work with lots of different models. Kara can sing a song about that. So then that is really key. Scale, finally. Nobody really knows what 1-0 scale is with models. Every model comes in their own scale, and their own original scale. So while we have this really nice zoo here, if I put everything at 1-0 scale, this is what it would look like. I actually went in there and looked at some of the issues when Kara was struggling. Oh, she wasn't really struggling. A little complaining maybe about some of it. These Google Poly models, while they are cool and hard to work with, but this is everything normalized, okay? But this doesn't mean that they all have 1-0 scale. If we normalized it in 3D software, then yes. But because these were modeled by various different 3D artists in whatever software they were using, probably blocks, yeah, nobody seems to pay attention to coordinate systems and pivot points and scale. And so this can be very painful, so keep that in mind. All right, I think I want to give you a few tips at the end. So when you design your virtual reality, you should think of it in terms of designing in terms of layers, okay? So there's a foreground where you put the 3D models, the spatial sound, so that's really the stuff that you see really close up. There's a midground. That is already adding to the atmosphere. So in terms of visual, I would say that's a terrain, any kind of environment, maybe some trees in the background, maybe trees, let's say, and the mountains, the rocks. Like I grew up in the Alps in Germany, so that would be the background. The background here would be a skybox. So a 360 sphere, is usually the outer bounds of our virtual reality, or a cube, depending on which software you're using. Could also be a cube box, but it's like a skybox in general. And ambient music, I would put, so it's not like really like, if you're pointing at an animal, that's foreground. If you have some kind of birds in the background or whatever, we have this rainforest sound, that would be ambient music. It's usually on loop, it doesn't react much. And you could still have some kind of additional background sound as well. I would distinguish this way. I was trying to explain these layers in terms of what that means for the 3D models and the 3D content, and then also the sound. These are all the things you put in the foreground. These are the animals. You can see some nice giraffes. This is the first thing I always look at, or this zoo plate here. And then we have the midground, okay? We're bringing in a terrain. In this case, this terrain comes with trees. They call this dressing. It's part of the A-frame environment component. You can configure that. You can style that. It doesn't have to be green. Can be winter. Can be whatever. It can be more abstract. But you see the difference? Creating more atmosphere. And then we're bringing in all the light and additional, actually a skybox. So we're changing the skybox here. And then also we're doing a little bit more. To be honest, this is the final design. We're also bringing in some of the light here. And it does, it's like, I mean, it doesn't exactly look like these really cool when they show you how they made the Marvel movies, but it's close, isn't it? Okay, this is when we really put everything together. An additional layer to really have some kind of light in the background, and we're changing the skybox a little bit more. So this is when you can then tune forever, but we also had a deadline. So I'm really happy with this example. So now I'm going to actually take you to the zoo 5 times, essentially, flying down into the zoo and showing you how we designed this in the zoo in layers. And it's also an example of iterative design, which is the next thing I want to talk about. So we are apparently, yeah. So here we are flying into the zoo. This was actually the scene that I had created as part of my office hours. So this was 20 minutes of work, I think, flying down this way. And then Kara came in, and this is a lot of the virtual world already in place. So we now have animals, and here this is our more environmental design oriented solution. In a third stage, we actually developed, and I would recommend we develop this in a separate scene before we plug it into the final version, a menu. And we then actually also brought in this petting area and petting zoo and feeding area. So the red one that's ahead of us. And then the final experience, taking these 2 lab scenes that we just had with a neutral environment and putting everything together. And here we are in the zoo, and now that is pretty cool. I wanted to show you this composition. And I want to talk about, in the last few slides, I want to talk about a few things as you iterate on projects, as you build larger projects. So a few tips there when you're designing virtual reality. So you should approach this iteratively, just like when you do web design or mobile design, you do it iteratively. So one way to do this here, think of it as a layered approach to environmental design, using 3 main ways to actually build your VR scene. You can start with 360 content first. You could then bring in 3D primitives, and then finally, only then, you bring in the 3D models. So the final 3D models, so the 360 is really just the placeholder for the environment. This could be a 360 sketch, and that's something that we'll talk about, or we have talked about. If you took the second course, then you will be familiar with that concept. I'm going to show an example in a second. Focus is obviously on planning the scene visually and spatially, very important. And you can do this spatially without depth, so 360 is a good way. Thinking around the user. Then you can actually work with 3D primitives. So this is what I would do if I were, like as a web designer, at least when I did web design, I would start out with the divs and color code them, and then I do CSS, and then I do responsive design. And so me color coding these divs essentially helps me understand the flow and the stacking and whatever I do in responsive design. And when I started out with the Detroit Zoo, I was also thinking in terms of these different kinds of areas, defining these boxes. I left them in the final experience because they didn't seem to be distracting, and they actually directly map to the map of the Detroit Zoo, so the areas that we have defined, and the colors partially match that. So I've been using the zoo example a lot, but I want to actually do an example here in the studio. So I took a 360 photo of the studio, it's here, and then I have a glitch project, and in this glitch project I'm just going to bring in that photo. I've already uploaded and prepared the scene and everything, and now it is actually visible, and I'm going to bring it into my scene. I load the scene here, and ta-da, here we are. And because it is a 360 photo, I can go into VR and actually view it in VR. This is what it would look like in VR then. So that was just the first part, using the 360 photo as a skybox. And now we're going to talk about interaction design quickly. So at the highest level, again, we can distinguish 3 types of XR interactions, and they also apply to VR, obviously. Implicit interactions, so camera-based, gaze, and eye. So eye and gaze-based, so gaze like head gaze, or eye gaze. Then system-based, so it could be location, time, counter, event, physics. Any of these could actually trigger some kind of interactions with the interface. So location, obviously, if you think of GPS, location-aware applications. Time, right, the time of day could make a difference. We could go to the zoo at night when it's night. and otherwise it's day, so we could manipulate that experience as well. And then explicit interactions. So really, here I would distinguish between user-based explicit interactions and then environment-based explicit interactions. So user-based, you're using a VR controller, you're pointing at something with your hand, finger, any kind of specific pose or gesture that you're doing, or voice commands. If you issue voice commands, so that would be a user-based explicit interaction, usually some kind of keyword, some kind of predefined command. Environment-based interactions could be marker-based or object-based. You're bringing like some physical object into the view of the camera. So this is mostly AR. But I wouldn't just think about it as AR. I mean, we have outward-facing cameras on most VR devices. It is uncommon at the moment, but we're going to talk about something like advanced techniques later on, where we bring in custom controllers into VR. So if you wanted to use, instead of this, if you wanted to use, I don't know, this remote control, because that is like whatever you're doing in your experience, it allows you to go to different parts of listen to different audio. You know how they give you these audio guides, and when you go to a museum, so that could be you don't want to hold this fat controller. So or you're watching virtual reality TV, doing it with a controller is a bit weird, but doing it with more like a remote control would be a different thing. And so if you wanted to track this, object tracking is something we'll talk more about in the AR portions, but it would be possible. And we can also do some combination of the above. So system-based plus user-based, so any kind of mixed initiative. So for example, you dwelling on a target. So it's very common in gaze-based, 3 degrees of freedom. So we do have a button here, but not all cardboards have a button. And so sometimes it's just like you like dwelling on an object. It gives you a fuse. That's something we'll talk about as part of basic VR experiences in the honest track, how to implement those things. And could be user-based, multi-model, so user plus user. So the user issuing two different commands and using different modalities like that's gesture and speech. So we have a lot of options, and we learn more about interaction design in this week when it comes to VR as well. So I wanted to continue my example. So once I have, for example, this 360 photo of the lab, I could enable a menu. Could bring that in. That could be a menu, that could be just all around me. I'm just using basic layout here. Each of these could be a portal into a different scene. It could be a loading a different scene. It's probably not the best kind of menu design, but it would allow me very quickly, I'm mixing here 3D primitives with 360 content. I just wanted to demonstrate how we can quickly prototype this way. And in VR, it then looks actually quite interesting. It feels already quite immersive. And so it's a nice transition from 360 to 3D. Each of these could also be placeholders for other kinds of objects. You could think of it as you selecting an avatar or something, and you see a preview, and I'm just using a box to visualize that first. But we could actually obviously update from this primitive, 3D primitive, to another kind of object, selecting your avatar. And those would be 3D models that I'll bring in later. So this was a lot of the fundamental decisions we have to make when we're designing a virtual reality. This was just the focus on the designing the environment part. We're going to expand on a few aspects of virtual reality. So we're going to bring in more interactions. We're going to learn about navigation and travel in VR. We're going to bring in menus. We're going to learn about how to select objects, ray casting, hit testing. All these things are coming coming back here and play a role in virtual reality as well. We're going to talk about colliders. We're going to talk about object selection and manipulation. So there's a lot of stuff that we want to cover. It's not going too deep, but I just want us to have a right foundation. Now, this is the course that is really focused on development. And the issue with that is that we are losing track of some of the higher level design issues that we should really pay attention to as we're designing virtual reality and augmented reality experiences. You actually, as a VR developer and designer, you have a tremendous responsibility. You have often full control over what users are seeing, how they perceive content. You can shock them. You need to be concerned about their safety at all times, and so you need to do the right thing with that responsibility. And so here I want to just bring back these design issues. I want us to always keep those in mind. So any kind of social or ethical concerns, so when it comes to designing a virtual reality, Obviously, it's isolated, but it could be a collaborative VR experience as well. So isolated because it's an occluded device. But there are interesting social and ethical concerns when it comes to VR. Again, the kind of content, how it appears to users. And on the social side, obviously these devices have the inside-out tracking parts have external sensors and cameras, and not everybody wants to be seen by them. It really depends on what happens on device and not, but most people just don't want to be in the view of these cameras. And so keep that in mind. Accessibility and next is accessibility and equity. So I really take issue with the problem that I really take issue with the decision to drop things like Google Daydream and Oculus Go, 3 degrees of freedom devices, affordable, relatively good quality, affordable devices to bring virtual reality to the masses. And that would have been a very great path forward for a lot of the things we wanted to do at Michigan. And so as a virtual reality designer and developer, I would still ask you to also design for lower end virtual reality headsets. So think about how the stuff could work in cardboard. Okay, obviously, so the thing is, if you only have cardboard, that's all you care about. If you have a more powerful device like a 6 degrees of freedom Oculus Rift, you usually forget about the people that only have 3 degrees of freedom, and that might actually be substantially more people. So this equity problem, not everybody's excited about VR, but there are a lot of people who would like to try it out and they just can't afford. And if you are developing a VR experience and you assume the latest and greatest headsets, that is, I understand. In research we do this all the time. But if you're developing a product, you should think about reach. And so you have also a responsibility there. Accessibility, obviously a key thing in VR, pretty hard, very predominantly visual. So we're excluding quite a lot of people from VR, and unless you're doing more with audio cues, and that's something to take into account as well. And then privacy and security. So yes, this course, like none of my courses are really focused on it, but every course touches on it. If you're doing AR, VR, you have to deal with privacy and security issues. A lot of it is, if you're just using some frameworks, I understand you're just using the framework and so you're subject to whatever the privacy and security policies are and how they're implemented. I understand as a developer, but that's not good enough. You choose the tools, so be careful what you're working with and make your decisions wisely. And that's all I'm going to say, because I do have opinions, but that is not so relevant here. I just want you to think about it carefully, what kind of devices you're working for. And I seem pretty neutral because I have all kinds of devices here, but that doesn't necessarily reflect how I think about the different kinds of vendors out there and what they're doing. So, welcome to the night safari at the zoo. So that's where we are. We are in the kind of like the beginning of the zoo, but we can already get a little bit of a sneak peek of the kinds of things we may be seeing on our little night safari here. So what I'll do is I'll do a little bit of a walkthrough of our zoo project, co-developed with one of my students, Kara Daly, and so that is, I think, pretty cool. So we're going to use this case study to learn about designing a virtual reality. So this is a virtual reality, and we can already kind of like walk around. I mean, I can walk over there and get closer to the animals. It is pretty far away, so what I can do, I can also teleport. And so one of the things we'll learn is obviously how to navigate in a virtual reality, including teleportation, which is what I'm showing here right now. And we are also going to learn about object selection and manipulation. So I can just go into the American grasslands here a little bit further, look at some of the animals we have. None of them are chasing us or anything like that. They're all pretty nice animals. And I can actually click here to go, it takes me back to the beginning of the zoo. So I can go to the grasslands, which is where we were. We can also go to the African grasslands. They are over there. So we're going to do that. I'm going to take us there. So this is the African grasslands with two of my favorite animals, zebras and giraffes. And so Kara is going to tell us about all the things she had to do to actually create this virtual reality. So, I mean, the story behind this project is that I started creating a zoo, a little bit of the map modeled after the Detroit Zoo here near the University of Michigan. And so it was in one of my office hours online on Twitch, and I thought, oh, that would be a cool example. And wanted to make the point that obviously it can be modeled after a reality, but after talking to the zoo, and I should be saying very clearly that this project was not done in collaboration with the zoo, but after talking to the zoo, there's actually a few things we learned what we can do in virtual reality that we cannot do in the real world. And one is actually getting very, very close to the animals. And so we actually have a feeding and petting zoo, which is something that, because of animal welfare, would actually not be possible in the Detroit Zoo, is something we can do in our virtual reality though. So here I'm going to show you, we can grab bananas and we can feed the animals. And I can like hop over there and like, yum, 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 yum. Want banana? No? You don't want a banana? Do you want a banana? And so we can kind of like give it, but it's kind of like, it doesn't really want to eat it. So anyway, we have physics and, oops, no, well, that one was pretty far away. And we can, the idea is that we can pet the animals, but they are pretty shy here. So it's like a petting zoo, but they really don't want to be pet. And so that is good, because the zoo told us that actually none of this would be done in the zoo. So we have, while it is modeled after the zoo, it is not the zoo, but in a virtual reality we can do these kinds of things. So what we learn about is how to kind of like pick up objects. So selecting an object such as this one, a couple of things are going on. I'm actually like going in here, and as the controller goes in here, I'm colliding with the object. So this object actually has a collider, as a bounding box around it. It's not visible, we cannot see it right now, but as I am colliding, I can then also pick it up. And you can also see that I seem to be pushing this banana already. That is because of how the bounding box is around it. I'm going to show later how we can render this differently. And I'm just going to walk a little bit down here to take this object, and this is one of the, this is actually the key, has the key functionality after which everything here was modeled, and we can teleport with it, and we can kind of like give it to people. We can grab it and rotate it with one controller. We could also, theoretically, we could also stretch it for some reason that is currently not enabled, but we can always enable this. We're using a control here, a component called Super Hands, and that one would make it very easy. And then it's like the prototype of a banana here, if you will, and you can throw it, and what it actually did just now is land on a plane, and that plane has a static body, and this dynamic body, this object will then stay there. So a couple of cool things we can do here, and I'm going to actually just go back there to our menu. So this is also a form of selection here. When I click this, it'll actually trigger the menu. So there's a lot of really cool areas here in the zoo. So we have the Asian forest. Let's go there quickly. And Kara is going to tell us how she really had to place all these animals, scale them, rescale them, do something about the models. They're all free models from Google Poly. So we didn't do our own modeling here. But when you work with a lot of free models, there's a lot of work that goes on to actually, that goes into this to actually scale these animals appropriately so that they kind of like fit together. So the giraffes are a really great example. The giraffes are actually really, really big in the original size, so you scale them down a lot. And so we went to the grasslands, the Asian forest. I'm going to go to the avian conservatory later. We were there, so let's go to the African forest. This is where we saw some of these. And what is also interesting is we can also just like continue to travel, and we can just like, if we feel like safe, so far everything seems to be good. They are kind of like looking at us all the time. So I keep traveling a little bit. Hello. This is the Asian forest, and you really actually don't want to be here. And these look pretty big, and we cannot even go further. That is interesting. So at this stage, it's probably a little too dangerous. So that's great. Kara thought of us, of our well-being, and so we just like say bye, and we keep going to the nicer ones, if you will. So we were here before. Just say hello again, and let us go to the menu. And I want to go to the Arctic. So for that one, it's pretty cute. We have quite a few little penguins here. They are all going well. They're all doing synchronous a synchronous dance here. We could refine this a little bit by having the animation start at a later time. And so a little bit of a delay between some of these objects, that wouldn't be a problem. We could easily do this. But it's quite cute the way it is. And we cannot teleport on the water. We have a little bit of a water here, and that makes sense. And then we have a few polar bears. So that is also cool. The last thing I wanted to show is the avian conservatory. Kara spent quite a bit of time to make this really nice, and it's very colorful. And we have animations here. And there's a really nice birds here. It's super cool, and they could even fly around more. We could put them on a path. So I'll talk to Kara later, and she's going to tell us about some of the ideas we still had, and then we kind of decided to, this is good enough. This is good enough for us to play around with and learn about the virtual reality. So it's pretty fun. And so that's it. So again, this zoo is our case study. We're going to learn about navigation. And yes, I showed you we can walk around, but we can also teleport. And we're going to learn about navigation via these menus. So jumping to each of these and then quickly jumping back to the menu, for example, and object selection and manipulation, for which we have this area here. And again, it's super cool, and I'm just going to throw it there. We could have added a collider to this box as well, so that's something we can still improve. But obviously this little table with the nice black tablecloth, if you will, is pretty nice. It seems like a cool little feeding area. So here we can learn about object selection and manipulation, and that is pretty nice. Also, we made it a night safari so that we can actually have this torchlight. I'm always fascinated by a virtual reality that plays nicely with light and with shadow. We didn't do too much shadow here. These animals don't have shadow, and the trees don't have shadow. Might have done this for performance reasons. This should work on the Oculus Quest we have. Actually, I'm running it on the Oculus Rift S right now, which is soon going to be outdated and actually discontinued. And so as we're getting ready for the Quest 2, we thought we'll just focus on getting this working on mobile virtual reality headsets that are standalone. So this is going to be a cool case study, I think, and I hope you enjoyed my little tour here with the night safari at the zoo, again, which was modeled after the Detroit Zoo, but it was no collaboration with the zoo, and the values of the zoo are very high, and we wouldn't have met them with this little playground of ours here, which is really primarily a case study for our XR MOOC. So in this video, we're gonna have a conversation with Kara daily. Kara worked with me on several projects and also supported this MOOC and actually taken some of my AR/VR courses as well. And the most significant contribution she made to this MOOC is actually helping us develop a VR project that we can use in the course to learn about how to design a virtual reality, how to navigate in virtual reality, so locomotion, and then also doing object selection and object manipulation in virtual reality. And all this will be based on our Detroit Zoo in virtual reality. And so I've invited Kara to talk to us about the project and review it a little bit. And well, so let's get started. Hello, Kara. How's it going?
Hi, Michael. I'm good. How's it going?
Yeah, doing fine. So, doing Zoom recordings all the time. That's how you have to do it.
Yep.
So, it's good to see you. So we are going to talk about the Detroit Zoo VR project. And so, well, I thought maybe you could introduce yourself quickly so we learn a little bit where you are, just a bit about yourself to have a little bit of opportunity.
Yeah, sure.
So
So I'm a recent graduate from the University of Michigan School of Information. I just received my master's in May, and I'm currently looking for a job right now.
that's good
And
to know.
that's me in a nutshell.
Okay, that's cool. And you've done a lot of user experience design and research projects,
Yeah.
and you have also worked on XR. You've taken both my courses, and as I said, helped a lot with this MOOC. And one of the
Yes.
projects, well, the one project we're going to talk about today is the zoo you created. And so let's look at this together. So this VR project actually started out in an office hour. I felt like I wanted to tell my students a little bit about geometry and kind of like recreating real-world elements in virtual reality. So I created this rough layout of the Detroit Zoo, and I started collecting some animals, animal 3D models. And I think that was the starting point for you. And then you took it over and you turned it into this beautiful project. So first question, like, what do you think? To which extent is it still, or has it ever been kind of like the real Detroit Zoo? And which parts are unique to our virtual reality version?
Yeah, so, when you handed me this project, you kind of had this skeleton version of all the different areas of the zoo, and I wanted to keep it consistent with what the Detroit Zoo looks like right now. So I did a little bit of research into what those areas look like, what they're titled. I know that there were some differences between what you had and what the actual Detroit Zoo is currently. So that was something that I wanted to keep consistent with how it is presently. And then also, I'll talk a little bit more about the models that I needed to use and the different types of animals, but I wanted to keep those animals consistent with what animals are at the Detroit Zoo today. So, you'd see giraffes and you'd see gorillas and you'd see bisons in the American grasslands area. And I wanted to keep that true to the experience as if you were to walk through the gates of the Detroit Zoo. But there are also some exciting aspects that we were able to incorporate, like the night zoo. That doesn't exist at the Detroit Zoo today, but if it did, I would definitely buy a ticket. It's really fun and exciting. And that's, the opportunity that VR provides. And there are also, like, the petting zoo and the feeding area that you don't have currently at the Detroit Zoo, but the feeding area was inspired by, when I was younger, I went to the San Diego Zoo and I was able to feed a giraffe, which was a really cool experience as a kid. And, you can't do that in every zoo in every city, but if you create a zoo in VR, you can make that possible.
Yeah, that's right. And I've actually tried it out, and you put a really big gorilla there in the petting area. So this guy
Yeah.
looks really buff. So I was a bit scared, but then I started feeding some of the bananas, and I mean that part shows basically what we'll teach our learners in this course. We'll teach it last. The object manipulation stuff, and there are some actually challenges. I think this is really some of the hard parts to do in VR, unless you use like a library, which we used there. But so I want to unpack a little bit the designing the virtual reality part. You've already told us about the animals and then making it consistent and then some unique aspects. So then when you normally go to the zoo, there's a lot of walking. So then in virtual reality, what are the ways in which we can navigate your zoo, your virtual reality zoo?
Yeah, so you can offer the opportunity to teleport around if somebody's using a headset with controllers, and you kind of skip walking down long roads to get from one end of the zoo to the next. You can kind of hop along your way and you're there much faster. And then the other way of navigation that I wanted to include was the menu buttons that you see. I was, coming back and forth from Boston. I had my headset, didn't have my headset, so debugging was difficult for me. So I needed to create something that I could debug with within the web browser. Yeah. And the other way that I wanted to offer a way to move around the zoo was through the menu that you see when you first open up the application. And you can see the different areas that you can navigate to. And for me, it was really something that I needed to do because I didn't have a headset to debug with. So I needed something I could use within my web browser or with my Google Cardboard where I could click and I could migrate across different areas really quickly. So I think in thinking about also the people who would be, maybe seeing this example who might not have access to a headset or don't own a headset, being able to offer this same kind of experience of moving along the zoo was important, I think.
Yeah, I agree. And it actually touches also on some of the more advanced topics, like how do you really design across a variety of headsets and support like 3 degrees of freedom, 6 degrees of freedom, with controller, without controller, mouse interaction if it's just 3D on a desktop. And in fact, your project can actually do all of this, maybe except for the feeding bananas part, which I think for that you actually need a headset. Because you need a controller and you need to, even though that we could also with some refinement we might actually also get it to work with the mouse, but it's just such a lot more fun with with the controllers.
Sure. And I think when I was designing that portion specifically, I was thinking about ways that how could I incorporate this feeding aspect for people who might be viewing it through a cardboard. And I remember working and trying to, tap on the banana and have it shoot across, but that's, not really true to a real experience of feeding an animal. It doesn't really work like that. So it felt kind of weird for me, and I think the way that we did it was truest to how it would be in real life.
Yeah, no, that's cool. All right, right. So I think, if I remember correctly, there was a lot of converting of the models and all that. So I'm going to ask you this question around what were some aspects that you thought were difficult to design and to implement? So we can also talk about development. So this is a portion in the MOOC. We are now really more focused on some of the development challenges and working with A-frame. So you can talk about A-frame and issues and all that. So I'm going to make a transition. So that's a cool overview of the project and a lot of the design work. And so I actually wanted to ask you, so which parts do you think were actually difficult to design and then also to develop and implement with A-frame and for the VR that you did?
Yeah, so I think it was challenging working with the Google Poly models because when they're built, they're not always built in the most consistent way on Google Blocks. Sometimes they're gigantic, and when you place them in your scene, you might actually be inside the model and you don't think that it's functioning properly. But once you kind of play with that, and the way that I set up my models was I had a code pen scene, and I made sure that they were all zeroed out on a flat level and all of the sizes were the same, and that allowed me to kind of copy and paste into the scene I was working with so that I could keep everything really consistent and I didn't have to go back and forth and trying to figure out what the sizing was or try to locate an object. Maybe it might have been placed inside of a tree so far away that I couldn't see it. So that was something that I think was unique to this project, where a lot of planning actually went into developing and getting the models into the scene that you see in the video.
Yeah, so we in this project, we didn't want to create our own models. We actually wanted to work with available free open source models, and we used a lot from, created in Google Blocks, as you said. And I think you're giving a really important tip that I also stress in the MOOC, which is like developing a complex scene like this in stages, and maybe even in separate scenes, and then even changing the layout, like what you described. This is like a really cool prototype or lab scene that helps you develop and get the dimensions right. And I think you did a really good job. Like the giraffes have a really good scale. There's still this one monkey that I'm scared of. I wish they were smaller. But that's cool. You're also showing a variety in terms of like models with animations, and some have really good material and look very interesting in some of the light. We have the torch light and all of that. So were there some issues there as well when you worked with these models, or was the material-wise, was that relatively straightforward?
So a lot of the Google Poly models were kind of inconsistent, but I ended up using the A-frame inspector to see if I could, change the lighting on them. And I also, when I was bringing in the forest environment that you see, I didn't want it to be fully wooded because, a zoo is kind of sparsely lined with trees and things like that. So I used the inspector to kind of edit those variables. And the more advanced animated models that you see are all from Sketchfab for free. So it was not something that I had done before, was include the animated models into any of my projects that somebody else had created. So that was a different experience for me. Typically I have just used Google Poly models where there's no animation involved. So that was a good learning piece, I think.
Yeah, that's cool. I saw I show the colibri, and there are some other models as well. It's really nice, and it actually, the other thing you paid attention to, and this seems like when you look at it, you just take it for granted. But like you placed all these animals, you rotated them a little bit. You chose some interesting compositions. You basically copy pasted the same models multiple times, but it doesn't always feel like that. So would you say it was would you say it was easy to create that VR version, or was it very tedious? How do you characterize the project?
I think it was definitely more difficult than other projects that I've worked on in your courses. But I was able to organize things and set myself up for success before I had actually started to build the scene, and that made it feel more approachable.
Yeah, that's cool. And I mean, the strategies that you shared with the prototype scenes and, breaking the project down into aspects. So when we look at the menu, we have like these maybe 9 or something different places we can go to. Did you create each of these separately, or like how did you plan out the project? Did you always work across the entire map, or did you focus on like scene by scene? I mean these locations, or how did you do that part of the project?
Yeah, so I kind of sketched everything out in like a physical sketchbook before I started, and I kind of put the camera in a place and organized the animals in kind of a really rough sketch just to kind of get an idea of what my goal was. And what you see in the final result wasn't necessarily the same as the sketch. Like, I was able to find the really cool conservatory model that I didn't think I was going to be able to find. And so there were those really cool times where, something exciting like that happened, and I kind of switched my focus, and I was kind of able to adapt there.
Yeah, that's cool. Well, when we look at it, I don't remember whether we paid a lot of attention to time, but what do you think? How many hours of work are we looking at?
Wow. I mean, I think we spent like probably a month or so on this project, and you and I kind of going back and forth. But the planning and then the implementation probably totaled like 20, 30 to 40 hours,
Right.
I would say. Yeah.
Yeah. So it's important that learners don't just like, oh, cool, I'm just going to do a zoo. Well, you really have to plan your time carefully. So, and some things, I think some things look decisively, well, simple, and then they're actually quite hard. Do you remember any kind of specific instances where something turned out to be more difficult than you had anticipated?
Yeah, the object manipulation was definitely tough for me. I'm not somebody who comes from a technical background, so writing HTML, CSS, using libraries has been something I've had to learn within the past 2 years in the program myself. So I know that you and I had gone back and forth about the object manipulation and how I might get that to happen, and so it was really a trial and error process with that, but it was definitely the most difficult part, I think, of the whole project for me.
Okay, so well, then speaking about this, really one, which was also one of my favorite aspects of the VR zoo, the the petting zoo and then the feeding area as well. So, do you remember were there any things that were particularly hard? Can you give some examples? I know the overall thing is difficult, but what were some of the challenges you faced there, and how did you solve it?
Yeah, so I think the object manipulation aspect was um, pretty difficult for me. Um, Initially, I wanted to start off with kind of the point and click and having the banana shoot across the scene so that people who were viewing from maybe a Google Cardboard or just through their web browser would be able to feed the animals just like somebody might be able to if they were using an Oculus or another headset. But I found it difficult to incorporate physics with that, and there was a lot of going between different libraries. I know that I tried to incorporate different Don McCurdy libraries and pick aspects of other ones, and it wasn't necessarily working out the way that I hoped. So that's when I kind of switched the experience to just a headset and controller guided animation.
Yeah, so in the end, we did end up using this Super Hands library. I feel
Mm-hmm.
so that basically supports a little bit of controller-based interaction, and so then you can reach into the objects and you can pick them up, and then you can move the banana to the monkey. But then when you release, you also have to maintain velocity, and this is where the physics kicks in. And so, like from a technical standpoint, definitely one of the more challenging interactions that you implemented nicely. I do like that the bananas are a little bit bigger than normal bananas. So,
Yeah.
were there some reasons why you made these objects a little bigger?
Yeah, I think that if you have like a larger object, it's, easier to grasp. And once you throw it, you can also see it move further out too. So that was just my reason for making them a little bit larger. And plus the monkeys were big too, so you needed larger bananas for larger monkeys.
Yeah, and it is a virtual reality after all. So why do we have to copy paste all that one to one? So I actually think you made really good decisions there. So that's cool. So there is actually a lot of interactivity already in the zoo. We can navigate, we can walk around, we can do the feeding. So we have all these things, and but we were also working on a time limit here. But I was wondering, what kinds of if you had to extend this project, where would you spend your time? What do you think would be the most important things that would maybe help immersion or make it feel like an even better virtual reality? What do you think, Kara?
Yeah, so in terms of immersion, I think altering the birds to kind of animate on a track within that conservatory would make the experience more realistic of being in, this conservatory with birds flying all around you. So that was something that I would have liked to do if I had more time on the project. And I also didn't play around with sounds at all either. So, maybe adding cows mooing within the American grasslands would have been cool and added to the immersion aspect. Or, when you pet a monkey and scratch it behind its ears in the petting zoo, having that monkey make a noise would be something that would add to the experience.
Yeah, I agree. Okay, these are cool examples. But I think, every project is time limited. I think you spent your time very wisely. You put together a nice scene for us to learn about. And now we also know which things we could expand on. So I think this is really helpful. Yeah, so these were really great insights, Kara. So, the one thing I'm doing with everybody I'll bring in here is I'm going to ask whether you have some last minute advice and some kind of piece of information for our learners. When it comes to developing with A-frame, that's something, and for virtual reality, that could be a specific advice or also something more general. What would you tell our learners who want to learn more about doing XR projects?
I think I've had the most difficulty in Michael's courses when I don't plan things out for myself, or I don't really set myself up for success. And in doing this project, doing all of the legwork in the beginning, like setting up the models and making sure they're all consistent sizes, really helped me be successful in this project. And I think that's just a note of advice that I would give to new learners is do the hard work first, and then you can play around with changing, the environments or moving around the models, but do all of that difficult legwork first.
Cool. All right. Well, that's cool. Well, thanks, Kara, for sharing this with us. We're gonna use your zoo to learn more about each of these aspects in the course. So I'm going to share a lot of these examples in a little bit more detail. But I also will include this interview with you because I think this is really cool to learn from the designer and the developer herself. So thanks, Kara.
Welcome to this lecture on menus and navigation in virtual reality. So if you have experience designing and developing mobile or web applications, one of the things you are very familiar with is menus and navigation in these kinds of applications. And there are specific design patterns, especially for mobile. The web is more like a Wild West, but for mobile we have specific design patterns. We have things like material design. And when it comes to menus, there are also specific guidelines on how to do those things. So for virtual reality, that's a bit harder. It's a 3D world, and how do we navigate in this 3D world? What are our options when it comes to placing objects like menus? How do you interact with these menus? How do you trigger the functionality of those menus? So that's something we're going to talk about. And also when it comes to navigation. So I'm really thinking about travel here. Which is basically the moving the viewpoint in our virtual world. Now the thing with virtual reality is it doesn't have to match the size of the physical world in which we operate, the VR experience. In fact, most of the time the virtual world that you see is vast. It's much larger than what you have available in terms of physical space. And so there are common techniques when it comes to navigation, so common travel techniques, teleportation, is one of them, and that's what we're going to learn about. So I'm going to start by bringing us actually back into the zoo. So we're going to continue learning from that case study. And here we are going into the zoo. We're going to basically come down and land there, and then you see the menu, bam. And that's what we want to focus on in this lecture. And that menu has the functionality of changing the viewpoint. It really teleports us to different locations in this virtual world. And I'm not operating it in virtual reality just yet. This is just me clicking it through. So this, again, the zoo was implemented in WebXR, and we are using A-frame. and we have a couple of components defined to actually enable this teleportation. And each of these menu tiles essentially embeds some code, triggers some code that actually then moves the viewpoint to a different 3D location. We never change the Y, we only change the X and the Z. So the Y is obviously determined by the height of your body and where your headset is actually along the Y-axis. So here I'm showing a little bit how we have done this a little bit behind the scenes. So each of these menu tiles has a location associated with that. And what you can also still see is that in these different locations we then have always kind of like also an immediate back button, and that back button takes you back to this ring there. That's our starting location. And yeah, so as you can see, I've removed all the animals in this for this little walkthrough, so we can really focus on the virtual world and just navigating in this virtual world. So in order for menus and navigation to really work the way we demonstrated, this is actually already involving a form of object selection. And so we're going to talk about things like ray casting and hit testing. We're going to talk about those things in a separate lecture. Here I really just want to focus on how do we navigate in this world. So I'm going to show you a virtual reality version of this, and as you might expect, I'm just picking up the controllers. We have no torchlight, but we have the laser pointer, and with that laser pointer I can just pick these tiles and it teleports me there. It keeps the orientation, so we don't adjust anything in terms of orientation. If you're looking another way while you're teleporting, then you would continue to look that way. There are other approaches to deal with this. So for example, in Steam VR or in the mixed reality toolkit for Unity, you have various configuration options when it comes to defining teleportation zones and hotspots, and then also when it comes to landing areas, should your viewpoint be modified further. So this lecture is focused on menus in the first part. So while designing menus and placing menus in virtual reality, you have 4 main options. There might be more, but these are the common ones. So you can fix it, so you can place it somewhere in the virtual world. It'll always be there, so it's anchored. It's kind of like what we would call anchored in augmented reality. It can be attached to the head, so to the camera, that is basically your virtual camera into the world, so that's a heads-up display essentially. I'm going to show you an example of this. It could be attached to your controller. When we track your controller, obviously, so virtual reality motion controller, we can just attach it to that. And we can attach it to the hand, like with the latest VR headsets. Even now in WebXR, I'm going to show you one example. We have hand tracking. It's really the latest. I'm glad that I was able to put this example in here. I was coding a little like crazy to get this to show you. In the end, it doesn't look that impressive, but I'm proud of it. So let's just get started. So here's the fixed menu. Okay, so the fixed menu is really, I'm just placing it in the world. It's fixed there. If you look somewhere else, basically disappearing from your viewpoint, it is at that location. And what I can do in this little example is when I click any of these tiles, a new cube will spawn. That's it. So there's no difference in terms of functionality. What I want us to focus on in this series of examples is where the menus are placed and how that actually changes a little bit the interaction as well. Even though, as I said, technically the interaction is the same. You're using Raycaster, you point at the menu, you get some visual feedback, and then you can actually trigger it. So the heads-up display, so this is now taking the menu and actually attaching it to your camera, to the virtual camera that you have. And I can still, the way I've implemented it here, I can trigger it so I can hide it and show it. But then when it's visible, it's actually really attached to my camera. Okay? So this is not a very common way to do it. At least the way I show it here, it could be it could be implemented more nicely, but it is an option. And so the benefit is obviously that it's always in the view. Or it's a disadvantage depending on what kind of experience we're talking about. But when it comes to choosing levels, for example, this might be useful. In this specific example, I don't like it so much because I'm manipulating the world, and so I actually want to see more of that. But it has the benefit, as I say, that it sticks with you with the camera, and yeah, it's not very popular. So a controller menu, this is actually quite popular. So in Tilt Brush or in many VR sketching applications, you always have some kind of palettes attached to the left controller. If you're right-handed, you put it you're using the dominant hand, the right hand, to actually draw, and the non-dominant hand, the left hand, would then be your palette holding some of the tools that you're using to manipulate the world. And here I show this example. So it's the same menu. I scaled it down a little bit. I just attached it to the left-hand controller, and that's it. So the interaction is quite smooth, actually. So I'm using the left hand to trigger it. I'm using the right hand to point at things using the laser pointer. That intersection will, so that hit testing and ray casting will only work while the menu is visible. So it's a very clean design, and you could do it with also kind of like going through, so push through, or using the laser pointer, as I showed here. And we are stacking these objects like forever. And yeah, I wanted you to see this one. I thought it was quite cool. And I want to show you this one, which is the hand menu. I'm particularly proud I was able to implement this with the latest WebXR. It just came out, so I'm doing this on Oculus. On the Oculus browser, the Oculus Quest. It's really the only browser right now that supports this hand tracking. It's experimental. And I've changed the world a little bit here. So I'm using these hand models, and I'm attaching the menu to the left hand. And I'm actually doing it in a way, so I'm tricking it a little bit. This is a one-sided plane that's only visible when I actually, like this way visible when I put up my hand like this. And you can see my hand, and it's actually being tracked in real time. So I disable the pass-through, and you can see how it's actually being tracked all the time. When I turn the hand around, it disappears just because of how I've designed the material of that menu. There are nicer ways to do it. You could, for example, you could look at the orientation of the hand and then really just show it when the hand is like this. But this is a very simple prototype, and it already looks quite cool. Because it's hand interaction, I can start playing with these cubes. I mean, playing. And it's actually quite interesting. So what we can't do with hand interaction like this is we can't have force feedback. So the advantage of a virtual reality controller would be that we could have, it has vibration motors. We could do something there. Obviously, the researchers among us would just say, oh, you just do muscle stimulation. So that way we can give you feedback even when you're just using your hands. And that's true, but it's experimental, and it's, as far as I know, not approved. There's no product when it comes to muscle stimulation that you can just like attach to yourself and do this kind of stuff. And if you're interested in, obviously, I'm just going through some of the basics here, but in my mind, I'm always thinking about some of the more advanced stuff, because that's what I really like to do. But it's important that we're building this foundation. But if you're interested in some of these things, I can also share more research papers in that space. I have nice colleagues and friends really working in this area. So we've completed the menu part, and now we're going to look at navigation. So navigation, I would say at the highest level, and that's something that I was taught by Mark Billinghurst, and actually a 3D User Interfaces book from Doug Bowman and colleagues is actually a nice book. So at the highest level, we can distinguish in terms of navigation, travel. Travel is the motor component of the viewpoint motion, so the teleportation part. And then wayfinding, which is actually when the user makes decisions about where to go, considering all their options. So it's a cognitive component of viewpoint decision making. We're actually going to focus on travel. Okay, I'm not going to talk about any of the psychological stuff, wayfinding, very interesting research in this space. While I was at ETH Zurich, I was working with a group a little bit that was really looking at airport navigation through different kinds of virtual reality simulation and models. That was very interesting. But we don't talk about this, we talk about just strictly travel here, okay? So travel, we obviously have menus as a way to travel. We did this in the zoo extensively. Teleportation. And that can be controller triggered, or it can also be menu triggered. But what I mean here is like there is a teleportation ray coming out of your controller, and it shows you where you will land. So that's what I mean by teleportation. And then walking, obviously you can walk. I mean, on a 6 degrees of freedom headset, it's very good if it's with inside-out tracking, or if you have a dedicated area for an HTC Vive, and really then you can walk within some of the lighthouse stations that you can set up. And there's obviously this idea of redirected walking, and redirected walking adds a shift function, some kind of gain function that actually adds, it propels, it's like mouse acceleration, if you will. While you're moving like this in space, and maybe, I mean, mouse acceleration would work with acceleration. Your mouse cursor wouldn't be a one-to-one, right? It would already be kind of like here. And so we can apply this gain function idea also for redirected walking. And that allows you to travel larger virtual distances in smaller physical spaces. That's one way to put it. I'm going to get back to this idea of redirected walking. It's not the focus of this lecture. It's very researchy, so we're going to look at it later when we talk about advanced techniques in the last week of this course. So let's focus on the ones in the middle, teleportation and walking. So I'm going to give you quite an extensive demo here on VR travel. And I want you to just watch this and learn. I'm going through a few of the things and even including implementation. Alright, this is my virtual reality travel demo. So I have a camera here. I'm not going to change the orientation, I'm just going to change the position. So I'm basically going forward, which decreases the Z. This is a right-handed coordinate system here in A-frame. And going backwards increases the Z. Okay, so if I go back roughly to 0, if I now go to the left, it decreases the X. If I go to the right, it increases the X. I can also fly in this demo, so I can take like 3 meters above, and I can also fly backwards to see the scene differently. And I'm actually printing out the world position. That's how I've configured it right now. And that is because I also want to show you teleporting. So I'm going to go into VR now, and there we are. So I'm going to get up actually. So seated, I'm like 120 high, it says. But getting up, I'm actually at 164. And so I'm making a little bit of room here. And I'm going to pick up the controllers just so that I have them. Alright, so same deal, right? Me leaning in decreases the Z further. Me stepping backwards increases the Z and gives me a different perspective, obviously, on the scene. And then leaning to the left and leaning to the right, you get the deal. And me squatting down actually changes the Y to like 1 meter. And normal height, standing height for me is, I don't know, apparently 165. Alright, and now I actually also have teleporting. So if I teleport over there, it's going to change my X and a little bit my Z. So not as much my Z, because Z goes this way. But if I go like diagonally like this, it's going to change my Z quite a bit. And now I can hop around in this world and then have to turn around now. I'm going to go back to roughly where I was, so you can see how the Z changes. And this is where we were initially. This is roughly our starting position is roughly here. So this is the teleport demo. And keep in mind that I'm printing out the world position. Normally this camera has a local position inside the rig. And I'm not showing the rig right now. And the rig is something that we actually take with us. So as we teleport, we take the controllers with us, and also the camera as well. So we're wrapping around this, both the head and the controller as part of the camera rig. I'm going to show you this quickly in the code. I'm just going to get out of VR. One sec. So we're going to go back into the code here. Going to reload the scene so it doesn't look that weird. And we are looking, this is what I was talking about. So we're going to go into the rig. So the rig is defined down here. The rig wraps around everything, and it has a head inside. That's our camera. And then the left and right controller. And if we didn't have the left and right controller inside the rig, I'm going to show you this. It's going to be very awkward, but it's the best way to actually demonstrate this. if I now run it in VR, which we're going to do one sec, just putting the headset back on my head. If we're now running it in VR, everything is weird. The controllers actually stay where I am, but I'm like teleporting somewhere else, just the camera, and the controllers are still over there, okay? So that's why we need to have the rig, so that we can actually take the controllers with us as we teleport in VR. So, I hope that demonstrates this a little bit. I'm going to undo this change so that future users will not be confused. And so this was my little A-frame VR travel demo. I had some fun putting this together. And there is more of this kind of content, so I share the code with you. You see the link down there. That code, especially if you're working in the honors track, part of the effort here is actually to share a lot of examples with you that I've actually developed myself over the years as I was teaching WebXR and A-frame. So there's a lot of, I think, useful snippets of code that when you plug it into your projects, you can actually build. At least students have done this in the past in my courses, build really cool, adapt my code and build really cool experiences. Or use it as a starting point. I mean, obviously they did a lot more than just use my code. So what I just showed you in this demo, as a quick recap, is I talked about this camera rig, okay? So let's say we are picking our new location. This is the teleportation ray that I was talking about. And then we have actually defined this rig around us. So this is the camera rig that includes your virtual camera, so the A camera or the camera entity in A-frame. In Unity it would be a main camera or an XR camera, and in Unreal it's a similar concept. Also the controllers are part of this rig. So basically it's an entity that contains the head with a camera and a left and a right hand controller. And now we are choosing our location, and as we travel there, the rig actually moves and we're teleporting over there, we're going over there. And that takes not only the camera there, but also the controller. So rather than just moving the camera, we are actually moving the entire rig. So as we travel, we also then take the controllers with us. Otherwise the controllers would, as I showed, would just stick where they are at the previous location. So it's important that we use this rig for travel inside a VR scene. So my last example here, that's going to be a cool one, I think, is based on Half-Life Alyx. So Half-Life Alyx is a really cool game. I'm not going to play too much here. I went into a portion where it is safe to show some things of this virtual world, and I actually did have to clear the scene a little bit. There were a few, let's say, things in the way of my demonstration. So I cleared it up nicely, and then I wanted to give you this VR travel demo. So what it shows is in the realm of teleportation, walking, and menus. It doesn't actually concern so much redirected walking. So it's really like an example of a combination of these techniques. In some form there is redirected walking in there, but it's not really the traditional form. So you actually see 4 different types of navigation or travel that are implemented there. Blink, shift, continuous head, and continuous hand. That's what they call it. So blinking means you're beaming towards the target. It's like zoop, zoop, zoop. Shifting is you're zooming towards the target. So the difference is that you are actually like, you can see a little bit, the virtual world is coming towards you. And when you blink, they actually, for a tiny split second, fade to black and then move you there and fade in again. So that's the difference between blink and shift. And then there are 2 other interesting methods. I still haven't really figured out how to feel good about them. So in one example, you will walk where you are pointing. So if you're pointing this way, independent of where you're looking, that's where you'll be walking. And the other example is you're just using the controller to trigger with the thumbstick, but you are walking wherever you're looking. And so watch as I actually demonstrate this. It's actually quite a fun demo. So one of the things I find interesting in Half-Life Alyx is how they've implemented different ways of actually walking. So the typical way is some kind of teleportation, but that is kind of also cool because they figure out whether you can jump somewhere or not, and then also visualize how you would land. And this part is cool because it does some kind of checking whether this is a legal move or not. Can also not go too far, and so have to go multiple times. Cannot go behind the fence, for example, but could end up there. and can explore a little bit. You can jump up there, and then that's it. You're not supposed to go there. Okay, so that's teleporting, and it's actually really well done. So I'm going to show you blink movement, teleport to destinations with a brief screen fade, the most comfortable movement type. And then I'm going to show you shift movement, teleport to destinations with a fast linear movement. And I'm going to show you move continuously based on your head orientation, that is the continuous movement. So basically you're looking where you're going, and then I'm going to show you move continuously based on hand orientation. I'm going to show you a different movement. The shift movement is still kind of teleporting, but it takes you there. It doesn't fade out, it just like warps you there. So this is still okay for me, so I don't feel any motion sickness. Some people may already feel some motion sickness. So, and I'm not sure what it looks like for you on camera, but probably you get a little bit sick when I do this too often. So this is the shift movement, and then we have we have continuous. And so the idea is that I look where I want to go and I press the controller forward. That allows you to explore the world, but it is, because I'm not personally moving, I mean it gets a little bit better if I like do stuff like this, but it's actually creating some kind of motion sickness effect just for me. The proprioception is like weird, like my body doesn't believe it's walking, and I don't even know which direction I'm looking. I'm still looking your way. Okay, that's fine. So, but basically where you're looking is where you're going. And I'm not sure, it would be nice to know a little bit more of the statistics. I wonder how popular this movement style is. When I watch people play this online, they actually do this quite a bit. So in this last movement style, you're moving where your hand is pointing. So you're going to the left or to the right. And so you have a little bit of proprioception because the body is doing something, but we don't normally navigate this way. So this is going forward, this is going backwards, and it feels a little bit like if you were Superman, then maybe it would be cool, but just like I don't think that this is a very popular style. So this was my overview of menus and navigation. There's obviously a lot more to be learned about menus, but navigation-wise, I think the travel techniques we covered at least the basics. Menus, it was a little abstract. I wanted to keep it conceptual. There is a lot of evolution when it comes to menu design. It's like with the web, it's like really evolving quickly. What are good ways of designing these virtual menus? But whatever you see come out over the next few years, it'll probably roughly fit into these 4 categories of fixed, HUD, and then attached to some kind of body part. So the controller or a part of your hand. Like I put the menu relative to the wrist that I was tracking as part of hand tracking that has just become available. So I think overall conceptually we're like in a good shape now, and while there might be specific and some really cool new menu designs in the future, we have covered them here, and you should be able to classify them at least. So, thanks for watching. Welcome to this lecture on object selection and manipulation. So, in virtual reality. So that's what we're going to do. I have the controller here, and I thought this would be a good way to illustrate what we're going to be talking about. So let's say there's some virtual content in front of me, and how do I actually like select it? So do I want to reach through? Is it enough to point at it? Do I have a laser pointer coming out? So these are some of the things we'll talk about. And then object manipulation is, let's say there's a virtual cube in front of me. How can I pick it up? What can I do with it? Like, do I grab it? Can I like rotate it? Can I use a second controller to, for example, scale it? So these are some of the kind of like, it's like pinch to zoom just with controllers. So how do we enable this? What are good interaction techniques for that? And I'm just going to introduce you to very basic ones here. There's much more to be learned about. But we want to be able to select things in VR, and we want to be able to manipulate the virtual world. And that, actually, both of these really increase the immersion, like enabling your users to be able to do something with the content. It actually increases this feeling of presence, of being there, and immersion as well. So here is our example. The zoo, you've seen it before. It's our case study. It's our virtual reality case study. I have brought back one of the menu items. So it's similar to the previous scene for the lecture focused on menus and navigation in virtual reality. Now I just want to focus on really this idea of selecting objects. What you see here is actually me pointing at these objects, and I added colliders around them, actually visualizing. It's like a debug feature for the physics. So that I use to illustrate that these are all active areas, and as my ray caster, like the laser that is coming out, I'm using A-frame laser controls here, coming out of my controller, as the ray hits it, we can detect this, and this is hit testing. And then we have like a little bit of interaction here, I mean just using the torch, but what we could do is actually have each of these animals play a sound or something as we point at them, or change their visual appearance, like have them look at you, trigger some kind of animations in these models. So we could do a lot more advanced things, obviously, but each of these would take some time, and we focused our energy elsewhere. So you can see how it works with the ray casting, and how I can hit some objects so the ray doesn't seem to go through them, and then other objects, just like the ray just shoots right through them, the objects don't seem to care. And that has to do with colliders. So this idea of really telling the virtual reality, well, the system behind it, which of these objects we should test, we should check for hit testing. Should we do this against all objects in the scene? That could be computationally quite expensive, and so that's something to pay attention to. If you wanted you could make this a little bit more explorative, right? Some of these animals could react, and others could just don't care or something. So you could play around with this. There are some specific techniques. If you want to build on our zoo in your own examples, that project is actually also available, and we can actually also use it. So I have examples where I just have one of the characters, like this giraffe, and then we also have this entire zoo. I also have all the steps of this project available. It is our case study, so as part of the honors track, we will be looking at this a little bit more. Now comes the cool part. The petting zoo. So I should say one important thing here. I said it's modeled after the Detroit Zoo, but this is completely fictional. It's a virtual reality. In fact, the Detroit Zoo has very high values, and feeding is actually not an option. Animal welfare, we talk to them, and animal welfare is obviously the #1 priority. So this is one of the reasons why virtual reality is cool, because we can do things. But I don't want us to suggest that the Detroit Zoo would have a petting area or a feeding area. Anyway, let's focus on what's going on here as a technological case study. So I've defined colliders. You can see them. They're visible now around the banana, pretty big banana, and I can pick it up, and we can detect collision between them. The colliders are actually box shape. They are not very good approximations of this banana. And so we could do that a little bit better with mesh colliders in Unity, for example, but in WebXR, well, there are ways you can configure it, but it's a little bit harder. Yeah, so I'm just making the point here that when we throw things over there, we have physics. So you could see how we determine the velocity of the objects based on previous basic frames and how the controller moved in each of these frames. So we're building velocity, we're building speed, and then we continue animating the object even when the controller releases it. So that gives the sense of you throwing that object. But then because it has physics, it needs to land on something. And so we put a virtual plane underneath so that these objects don't fall into whatever is down there. Otherwise, it's endless actually. So that's important. So physics, combining physics with object manipulation actually makes for really realistic virtual reality experiences. Lots of cool examples, and I think I would always consider adding physics to an experience like this. Otherwise, the objects would just be floating in the air, And that's good, for example, for prototyping and kind of sketching activities. That makes sense. You don't want everything to drop. You actually want to sketch mid-air. But for our zoo, we wanted it to be a little bit more realistic. So I think I've covered most of it. There's an original video where I really do talk through all the aspects of the zoo, but I want to move on in our lecture. And I want to talk about virtual reality interactions. We have a broad range of interactions. If you really zoom out at the highest level, we can distinguish between travel. So that's a form of an interaction in VR, and that can happen explicitly and implicitly. We have object selection, so picking objects in the world. And we have object manipulation, so modifying objects, manipulating them in the virtual world. And we're going to focus on the latter too, because previously in the lecture focused on navigation and menus, we talked extensively about travel. So let's focus on object selection and object manipulation. So when it comes to object selection, we can distinguish between far selection and near selection. Actually, these apply both to manipulation as well. But I'm just going to focus on the first step. Before we manipulate anything, we need to select it, okay? So let's think about it this way. And so for far selection or manipulation later on, we use raycasting and hit testing for object selection. I'm going to demonstrate this in a video. And for near, we have to do it a bit differently. So we actually define colliders around, for example, the virtual reality controller or your hands for hand tracking based examples. And as you kind of like collide, so you're like intersecting in a virtual object, that's when we do collision detection, and that's when we then trigger the selection. So here I show a raycaster example. This is the typical raycaster coming out of a controller, for example. And as we intersect with that cube, we could render it differently, change the appearance, give some visual feedback. So basically, we could do continuous hit testing, and I'll visualize this on this plane. So me pointing somewhere on this plane, we do continuously find the intersection point. And so, for example, as the user then like triggers, clicks the controller or taps the screen, we could find that intersection point. So tapping the screen in AR, this gray surface could be a detected plane from the environment, and then we would place an object, for example, at this intersection point. So that was raycasting and hit testing. So the combination of, again, let me use the controller, like shooting a ray into the world and then determining which of the objects it hits. And we actually really get the intersection point, and that's where I've spawned that sphere. And so that can be very useful for all kinds of applications, including travel. But really, if you just want to figure out which of the menu items you, for example, select, that's also the same technique. So we're going to look at collision detection. So raycasting and hit testing is what we do for far manipulation or far selection. And for near selection and near manipulation, we really have to approach it differently. So we're doing collision detection. All right, so here we have an example with colliders. I show the colliders around the hands, and so I also show colliders around the plane down there and also the box. And so now I'm going to teleport over to the box to show you a little bit of an example. So as I reach into this box, you can see I'll reach into the box. We actually detect that kind of collision. So there is a sphere collider around the hand, so it's not like the actual fingertips or anything like that. It's actually a bit more sensitive. And as those colliders collide, we detect a hover, essentially. And so then I can start interacting with the object. I have kind of like hovered it, so I've selected it. And so that works with either hand or both hands. And I'll render a little bit of visual feedback. So the collider of the box you can see a little bit. Maybe now it's a little bit better. You can see the outline there. And also this is obviously an object that is standing on a surface right now. So we have physics for that as well. So the two main building blocks. Okay, we have raycasting for far selection, and we do collision detection, so really defining colliders around, well, our hands or the controller. In this example, I was using a virtual reality controller, but I was showing a hand model. So we define a collider around it. As it enters a virtual object, we can detect this. And yeah, So this idea of colliders is really, really fundamental when it comes to implementation. So in both, actually in all these systems. So in WebXR, which is A-frame based, which is 3JS based, for all the interactions you define colliders. Per default, we have box and sphere colliders. There's also this idea of an AABB collider. And that's the one that I was using here. So that's something that you could use in A-frame. And yeah, there's also the superhands library, which then defines all of this stuff. And that's my example in the collision detection. I was using superhands. And that's for VR collision detection. That's pretty cool. And you have a number of options there. You can actually really manipulate the scene then. So that's what we're going to look at next, manipulation. So object manipulation is really about modifying objects in the world. Okay, and so we have a number of options here. So superhands, as I just said, implements 4 of them. So hover, grab, rotate, and stretch. So in other words, changing the object's appearance is something that you could do on hover, and then change the object position. Obviously, as we grab the object, you want to drag it and you want to move it around. Rotation, you allow the user to change the orientation of the object, and this can be done with one hand, or in many applications it's actually done with 2 hands or 2 controllers. And stretching. So same idea. In this case, we definitely need 2 controllers in the superhands case. I'm going to show you this. All right, here I have an example of superhands. So this is an example of far manipulation. So I'm using a laser pointer to go and grab. I'm now gripping the object and then I release it, so I can lift it and release it again on this platform. And I can also throw it. Woo! And this would be an example of far manipulation. Okay, now let's look at near manipulation. So here I have an example of near manipulation. So I'm too far away from the cube. Pointing at it doesn't do anything. So no ray casting, no laser controls. And so me trying to interact with the object doesn't do anything. But then I have teleport, so I can teleport over to the object. And now you can see as I reach into the object, it actually detects this. I can do it with either hand. And so this is essentially hovering the object. It's collision detection, and so now I'm inside the object, and now I'm outside the object. So I'm entering the object, and now I'm going to use the grip to actually lift it. So I can lift the object, and this is grabbing it. So reaching in there, grabbing, and then I can lift the object. So with a second controller also entering, I can not only grab and lift, but also stretch. So here I'm going to move these controllers together or further away, and can just use one hand to lift it or rotate it. So one hand rotation, 2 hand stretching, and adjusting the size of the object. And then I can just release it and it reacts to physics. And I can also grab it again and do the favorite thing that I always like to do and throw it away. So that was far and near manipulation using a virtual reality controller. What if you want to use our hands? So let's look at hand manipulation. So this is a demo where I have lots of cubes on a virtual table in front of me, and I have hand tracking. And so I'm going to show you, this is really like my physical hand, and it's tracked in real time. And I have a hand menu associated with it, and so this uses essentially Oculus Quest hand tracking. And the way I trigger this menu is with a pinch gesture when the menu is visible. And that's how I've implemented it prototypically. And then we have physics enabled. Oops. Sometimes some funny things happen. And you can like grab these things, and basically physics works with both hands, and can insert new objects and can like play around. I mean, you could theoretically, let's say, plan a little bit. The scenario could be like planning city layout or something with cubes. I don't know really what the scenario would be. So hand manipulation is really one of the latest things you can do in virtual reality. It's only available right now on the Oculus Quest, at least at the time I was recording this. It was very experimental, just came out a few weeks ago, and I just had to implement it and show it to you. I think it's pretty cool. I do think that it will, this is based on WebXR, so it's going to have an impact on how we interact in the future with web content. At least that's what I strongly believe in. That's what I also focus on in a lot of my research. Some of it was in collaboration with Mozilla when they were still focused on WebXR. It's been a tough week last week where there were a number of layoffs in Mozilla. So, WebXR is not the main focus anymore. So let's see where that is going. But I'm going to show you two more examples. So here, next I'm going to show you manipulation in Tilt Brush. So this is Tilt Brush. I have the menu. I'm using the left controller already to manipulate this object, this menu attached to the left controller. And then I was just picking a color, and now I'm sketching in midair. And that is a form of manipulation because we are spawning actually new 3D content. And the way this is done is in a very performant way. These are not little spheres that are placed in there, which might be the first thing that you might be implementing when you want to do your own sketch tool, or some kind of lines that you're adding to the scene. No, that is really manipulating the mesh, and that is a more advanced way of implementing this. And Tilt Brush is really quite advanced because all this stuff is glowing and being animated, so it's one of the most amazing sketching tools when you look at it. It's not particularly useful for a lot of the activities that I need to do, like planning a VR scene. There are better tools for that. But there are some really impressive artists out there who use Tilt Brush in a really, really cool way. So, so that was a form of manipulation, a lot of things coming together, obviously selection and manipulation in Tilt Brush. Let's come back to Half-Life Alyx. So I have a last example here for you. One of the things that I really liked is a whiteboard. That was it's early on in the game. If you play it, it's really quite well done. And there have been cases where actually teachers have used this in class as a gameful learning way. So, right. So now we can sketch. So this is Half-Life Alyx. It's one of my favorite scenes. It's right in the beginning, and we could grab a pen and like sketch out a plan here. And so this is kind of like if you want storyboarding in VR. So this could be my 2 frames or something. Oops. And then you have an eraser here. So make sure that this might have been important information from the previous person. But let's just like leave it there for now. And sketch in something cool in yellow. And you don't even have to press anything. I mean, because the idea is that you are in virtual reality, and I'm gonna pick up this pen and control and fit. Oops, I'm just dropping everything. I mean, you have to use the controllers to hold things, but otherwise it's definitely that pen just fell. It's definitely one of the better sketching interfaces that I have seen. You have to obviously release, and there we go. And could also try to, fine-tune some of the things here. So this was my lecture on object selection and manipulation. It was very example-based. We didn't go too deep on the coding part. That's what we're going to do in the honors track. So check that out if you're interested really in how to do these things in more detail. I have lots of examples, lots of code to share. And so let's look at this together. But we have the basics. And if you just want to zoom through and go to the next stage, this is more or less the VR portions for us. We're going to learn more about AR in the next module. But really, there's a lot more content in the honors track. So I would invite you to check it out. Welcome everybody to this lecture on basic virtual reality experiences in WebXR. So we're going to use A-Frame, and this is going to be a little bit more hands-on. You can see I'm already kind of like almost ready to jump into VR. So for the majority of this lecture, I'm going to be using the Oculus Rift S. It's connected to my computer. Very quick setup. I can just jump into VR on the computer and get the controllers and show you things. So that's important. But keep in mind, even if you don't have this headset, cardboard with a smartphone would be a possibility for the majority of examples in this lecture, if not all of them. I think all of them. And I'll say later if that's not true. The problem with that is I would always have to switch to the smartphone, type in the URL, and run it. And I'm gonna avoid that just in the interest of time. And I can just run things quickly, but they would work in the cardboard. Okay, so keep that in mind. Not gonna show anything beyond cardboard in this lecture. So I have like a starting point for us here. Where I kind of like want to be at the end is this final example. So I'm going to show you my starting point is this, and where I want to be is actually final HTML. So this is where I want to be in the end, and then I want to be able to just like go into VR, and now I'm actually in VR, but for you to see this, I'm going to show you the Oculus mirror that I have here. And now you can see I have the giraffe. I actually have the controllers in front of me. And I will have teleportation in there, so I can actually teleport around. I'm not going to get up and all that in this lecture, but I could essentially walk around, take different angles, and look at the giraffe. And there's my giraffe, and I can go back. I can also like be underneath, and then I just had to do this kind of turn because although I'm on a swivel chair, it would be dangerous at some stage. So. Cool, so that's my setup. So the mirror here so that you can see things. I am using Firefox so that I can actually jump directly into VR. I'm going to actually do this project here, and I'm going to share this with you later. This is part of my XMOOC glitch project, and I'm just going to go back to our starting point. I'm going to build this scene for you, just so you know this is what it looks like right now. Just a little giraffe in there, and we can already go into VR. I'm just gonna escape quickly, reload the scene. So this is our starting point, okay? So all I have so far is a giraffe that I got with Google Poly, and a plane, and I put it on a green background, and I just showed you where we want to be. So this is our starting point. So far, not too much in this code here. So I'm calling it Basic VR. I'm using A-Frame, the latest at this stage. I'm sure they're working on a new one already. I have the Google Poly load component in here, so I can actually get my Google Poly. My Google Poly that I'm using is a giraffe. It's actually from Google. Here I specify the Poly ID. I have to use an API key. It would be great if you weren't using this one, otherwise I will get into trouble. I've already kind of like figured out positioning, rotation, and scale. Otherwise it's too big. And in fact, I'm actually going to make it probably a little bit bigger for some of the VR examples. And I'm going to change it and make it smaller again for AR. That's not going to happen, I guess. And so we have a plane. We have a green sky. That's our starting point. Anytime we can go VR. Won't render here, but renders here. I don't know why this is the case. It's just recently. Anyway, in this example, no controllers, okay? No controllers. Not rendering yet. We're going to get the controllers in there. And so we're going to make it a VR scene. So right now it's just a 3D scene. And I'm going to reload this very quickly. So just a 3D scene. So the first thing we're going to do is, I showed you where we want to be, so we don't have to do that. We're going to look at, so we're going to do a basic VR experience, okay? So 3D model, we have, maybe animation, maybe I'll do that, maybe I'll rotate it or something stupid. We'll see. Lights and shadows, they are already there, I'll show you. And usually you would have some kind of like cursor-based interaction. So what I mean here is the cardboard cursor. So anyway, first things first. Make it a VR scene. So I have on CodePen, I have a template for us. So that's this one here. And it doesn't contain CSS or JavaScript, so I'm just going to go full screen on that. Doesn't look too impressive. Actually has a little bit of interactions that already work also just with the mouse. There's actually quite a few things going on here. And actually running in VR. Yes, so we're going to go full screen. I don't want to actually close this. I should keep that in mind. So this is the VR scene. And now it has support for controllers. It actually has laser controls. So this template is a really cool starting point. And on one of the controllers, if I remember correctly, yes, here, I put on the grip button, so not the trigger button, because trigger is to click, and grip is, at least on my Oculus right now, and you may have to adjust a little bit the button configurations, but this would allow me to teleport. And I can point at things here with my laser controls. So what I'm going to get from this example is well, later I'm going to get the teleport controls. But I said we're going to do cardboard compatible stuff only. So then I'm going to get not too much actually. I'm going to get the hands. So I have them. They wouldn't show on. So this is like that part that I just copy paste into my scene. So I get the camera rig, I explained that in the lecture, I get left hand, right hand, we have laser controls, left and right. We're gonna have a mix in here later. I'm gonna do that part later. That would actually give us the functionality for the teleporting. I'm doing it via a mix in. But so right now, when I now load my scene again, I'm gonna go into VR and I'm gonna show you in here. I'm gonna go full screen. Set this up, then I should be able to see my controllers. Okay, I actually have laser controls now, and they are intersecting with anything and everything they see right now, and so that is a little bit of an issue, and I'm gonna fix this by when I have a raycaster. That would have been the mix-in would have done that. We're going to fix that later. Okay, so the main point is these hands wouldn't actually show up on cardboard. For cardboard, we should probably have a cursor. I'm going to get that too. So I actually have a different template for cardboard, and I'm going to get to that one at the end. So the first thing I wanted to talk about is actually animations, right? So we have a 3D model. According to our checklist, we have the 3D model. I just use a Google Poly, and then we're going to do animations. So let's look at my animations example here. So no CSS, no JavaScript. How am I doing this? A lot of things are going on. In fact, we can also look at this in VR. Let me just make sure that only one of these is actually in VR. I'm going to see animations are there. And this is what it looks like for me now in VR. And yeah, this is, I'm going to adjust the settings a little bit. This is, yeah, so it's a disco. Club. Yeah, so this is interesting. I just put everything together here just to show how animations work, and there's obviously a lot of stuff going on. So let me see that I can grab animations. So here, look at this. I'm just going to cancel. One of the animations does rotation. So on the box, there's a lot of stuff going on. Some of the other things are doing scale. And we can also just actually do position. So I'm going to grab one of these as an example for me. I'm going to add that into my scene. We're going to animate the giraffe. Okay, so here I'm going to, that's how you can use my examples and learn from them. So this one now wouldn't be a cool one. It would just like rotate this giraffe in a very weird way. You can see where the pivot is, and yeah, I actually went on, I guess. So we're going to do property rotation is very weird. What I'm going to do is I'm just going to do a 360 around the Y, and then it would be a little bit less weird, but it's still weird. What did I do there? Rotation 360 0 0. Oh, we have a different starting rotation. We should keep that in mind. So we need the -90. We need to leave that one, otherwise the model wouldn't be right. So this is now alternate. We don't want that, so we're gonna not do alternate. We're just gonna keep looping. So if I reload this one again, it'll just like go in circles. It should go in circles, but it will actually then reset. Okay, so this is a little bit uncool. It goes from -90 to 360. So it should go to, yeah, we almost need to have two. So I can start from 0 and then this one would be better. So then it starts like this way. And we can also like have in terms of animations, there's a few things, but I'm just going to quickly open A-frame animation as an example in here. And one of the things I'm looking for is obviously this is where you can find all the information that you need. One of the things I want to find is the easing function. And then here it says easing, and I'm going to do linear. So easing linear, I'm just going to add that here. Easing linear. And then it'll look a little less weird. It'll be smooth. It'll just always continue moving, moving, moving. And we can see it in VR as well. And now I have a giraffe that keeps like rotating. But I don't want that. I mean, what we could do is a little bit left, right, just to have a little bit of movement. And so if we started from we can have a little bit of subtle movement if we want to. So I think this was 90, and then we can do 92 just to have it moving a little bit. Let me see how that looks. So, oh, this is now the back. Okay, we need -90 to move it to the front, and then -95 over 2.5 seconds. Let's see what this effect looks like. Obviously, this is a little bit of experimentation, and now I'm going to do alternate. So I'm gonna go from -88 to -95, and I'm going to do the alternate direction. So then it moves a little bit, and it'll look like, hey, this is a giraffe, and it's moving a little bit. Okay. So, and maybe you want the easing. There are other easing functions. Let's see what other easing functions we have. Ease in, quad, sine, ease in, back. Let's do elastic. Ease in, out, elastic. So let's copy this one. Let's see what that feels like. So something to play around with, obviously, as part of the animations. I'm probably already spending too much time. I mean, it looks a little, let's test it in VR. Yeah, so full screen again, mirror. This is just so you can see that you can see what I see. And yeah, I mean, it's obviously not too crazy, but it's better. It's much better than the rotation before. What do you think? Okay, so I'm going to actually move on. We have animation now. So, and I said we have VR. We actually have the controllers in there. We're going to have lights. Okay, so my light demo is another starting point here. So we're done with animations for now. This is my light demo, okay? And actually I have the CSS I use mostly for this toolbar down there, and also the JavaScript. So all we need to see is the light in here. So we have two lights in here. We have an ambient light called A light and a directional light called D light. And so here I can actually make it pretty dark or just reset. So this is the original ambient light. I could also change the ambient light in this demo to blue, for example. And then there is a directional light here. It's always hard to see where it is, so I can go into the inspector and zoom out a little bit. So the directional light is actually here, and the ambient light is usually at the 0, 0, 0. Directional light is that's the default light inserted by A-frame. So at 1, so it's actually usually behind the camera. That's interesting. At the height of 1 meter and then a little bit to the left. So it's shining, and you can see, I mean, maybe this is how it's gonna shine to the center, okay? So it's going down to the center. If you move it further away, this is going to change things a little bit. So you can play with it here in the inspector. But keep in mind, you playing with the inspector doesn't update the code. You can see how it shines to 0, 0. So obviously, if you, for example, if you move the box out, this will also look a little different. I thought it would look a little different. So let's just move the light. The light is always going to be at 0. And okay, so we're going to go back to the scene. Let's say, so you can play around with this A-frame lights example here. I'm going to get my own lights. So I'm actually going to take both. These are the default lights, but since I want to change the lights a little bit in my scene, I'm going to just get them in here. We have the sky, it's pretty green. So what are we going to do, a night safari? What do you think? I mean, we wanted to do a night safari. Cast shadow. Why is this the attribute name of cast shadow? Must be in lowercase. Yeah, okay. This is interesting that this actually works. I doubt that this is correct, but okay, fine. We'll just leave it the way it is. I mean, I programmed this some time ago, so maybe it is fine. So let's see what we just have. So now we have, this is the same light as before, so no change. Oops. Yes. Okay, let's close the template. We are gonna get actually the teleport controls later, but let's just focus on one so that I don't always do the mistakes. I'm gonna reset here. So this is our light. And I'm gonna adjust it now a little bit. So ambient light, let's say we make it a little bit darker, so 777, and so that would make the whole scene darker. Okay, you can see how the giraffe is now, yeah, can actually make it even darker. So then we can later have the torch light if you wanted to. Okay, so pretty dark now. And we can also change this ambient light maybe to 888. And position, yeah, I would like it to be actually more like from the right. I'm going to put everything at 111, so I'm going to have it more like from the right. And what I could do is actually I can change it to a spotlight. Maybe it's just called spot, I forgot. Let's see, A-frame, documentation light, and ambient directional hemisphere spot, so then type spot. So it's not called spotlight, it's just called spot. And so now we have a little bit of, it's a little bit here, but so my giraffe is at -5, and so for the light we can have a target element the spot should point to. Okay, so we're going to give it a target giraffe. It has that ID, so let's see whether that kind of like changes anything. Doesn't change too much. I'm going to have it actually higher, so, and I'm also going to have it roughly like more like above the giraffe, but maybe at -3, and so maybe that changes things a little bit, not too much, but it's probably shining on its back now. Okay, time for the inspector. So what did I do? Where is my directional light? So it is probably shining at the giraffe, but that's interesting. Not too, oh, I guess actually the intensity is not very, you can see a little bit of it, but the intensity is not very great. So angle, maybe we can make it a larger angle. Okay, leave it at 60. Since I made it a spotlight, we should probably make it bright and put it roughly there. Now we're talking. Okay, And then intensity, I'm going to make it 0.9, 0.7, and maybe make it more like a spotlight. Okay, so maybe just 20 and 0.75. Okay, how would that look? So then when we are here in the beginning, this is interesting, potentially. I like it. So I'm going to inspect the scene again. What did I do? So I put it roughly at what low position? So 3 minus 1.7. So we're going to copy this more or less. Copy everything. So I'm just going to copy. So technically, you could do it. You could really do it step by step. I know it's a little bit. So 3, we can remember this, and this one, if I really wanted to have it like this exactly, then this is where I have it right now. I'm going to round it up a little bit, and here I'm also going to round it up a little bit. So leave it there. I said FFF. Angle I put to 20, and intensity color FFF. Can we change that? Intensity 7.5. Okay. Let's see. Oh, let's reload. And there it is, the way it was. Okay, we have light. Animation, we have light. We're cool. Okay, we're good. Do I have the mirror? No. Always forget the mirror. I'm sorry. I'm not used to developing with the mirror in the background, but here we go. And there is our mirror. And yeah, for me, it looks already quite cool. So in my shadow example, you see a lot of the stuff that is actually the theory behind the shadows. You actually see where the light is coming from here. There is actually a shadow camera that I show. And if we go into the scene inspector, zoom out a little bit, then you have that pretty nice view. And the light that is the directional light is the one with the shadow. So this is the directional light. I should have named it here, but if I move it up, you can see how it does change a little bit the light on the scene. And it always shines at the center. So I'm going to actually, it's a little crowded in here. So let me give it a little bit more like this. Okay, and so now as we kind of like go by, you can really see how it changes a little bit the light. I always like to play with light and shadow. Also, I was just looking at the light. Look at the shadows now. So you see how the shadows are obviously moving left to right. And so obviously if we animated this the spotlight, that could also be very interesting. Okay, let's see that we get some shadows in here. So we have cast shadow true, and let me see, I'm still not sure that I'm doing this the right way. So close this. I focus on the left. The Oculus is getting heavy, and so okay. So here we have the, yeah, this is probably the way we should do this with the shadow camera. I'm just going to do it this way. This is the directional light. And this cast shadow seems wrong for the ambient light anyway. Ambient light, cast shadow. I don't know what this is. I don't think this is right. Does ambient light actually cast shadow? So shadow. Ambient. So we recommend to have ambient light such that shadowed areas are not fully black. And like I feel like ambient light cannot cast shadow because it's just like lighting the whole scene. Configuring shadows. So light types that support shadows are point, spot, and directional. Ha ha! Good. So I don't know. This must have been, you know, the previous Michael. Anyway, so new Michael obviously knows a little bit better. So for the light, we can do it like this, the way I had it here, but I'm actually gonna do it slightly differently. So I'm gonna copy this whole thing, write it a little bit differently. It's gonna be the same functionality, just we're using the whole light component. So I'm gonna use an entity, and it's gonna be the same thing. I'm gonna make it a spotlight, cast shadow true, angle is 20, so we're gonna do that here, angle 20. Position and all that we're going to leave. Intensity is actually going to be 0.575, and color we're going to put that in here. Yeah, so have to rewrite this a little bit. And now this is going to be my light component, okay? So everything light is now in one thing rather than having like a million of these properties. All I do here is specify everything light as this light component, and the target is also part of light, and so this is an entity now, not a light anymore, and then we just have a position. And so here I say target giraffe, and then we are cool. And from time to time you could format this file and see what it does. It does break things into different lines, so that makes it, sometimes it breaks it up like crazy, and so I don't actually like this. I'm just going to undo this. I just wanted to show you it's possible. So here we can have the light in the next line, maybe a little bit like this, and we're going to move the position up. So okay, so now I'm getting crazy in terms of coding, but okay, here we go, loading our scene, and we're going to show you there is our spotlight. You can see it now with the shadow on, but with the shadow camera on. But the problem that we have, cast shadow camera is visible. I'm going to just sort this a little bit differently, angle and target. So the problem is we don't actually receive shadow, I believe, on the plane. So we're going to do that, plane here. If we add shadow here, it should receive the shadow. And yeah, since we have the spotlight like that, maybe this doesn't work yet. There could also be a problem with this model. But I do, okay, let me debug this. So I'm going to bring this in here. And why is this not working, huh? That's everything that will go wrong can go wrong. Here is the light. If we change the light, it doesn't change anything to the shadow. I'm going to make this plane just a little larger. So 10 by 10. No, I don't actually see any shadow. Oh, the model may not have shadow. Okay, we actually, yeah, all right. So that is, well, this could happen to you too, right? Happens to the best. So here, gonna have shadow for that model, and then, yay, you see it? You see it? Okay, we have shadow. All right, perfect. So, and the shadow is also moving, but for the purposes of our demonstration, we're going to actually increase the size of the plane, give it a little bit more space. Oops, that would be crazy. So 10. Now here we go. Huh? That looks interesting. I'm going to move it a little bit backwards. So minus. Okay, I made it a little bit too. I think this is fine. And so. All right, and then I'm going to move it a little bit backwards to -6, and that moves the plane a little bit like that. Now suddenly loading takes a little bit of time here, but it's okay. So now I'm actually kind of like happy. Actually, I'm going to make it a little larger. Sorry. All right, so so that we have like, okay, you can. Isn't that a great little scene? All right, we have our giraffe. It's moving. It's more like a circus now, right? It feels like a circus. All right, cool. So we have light. Yes. So we are. Where are we? We have lights, shadows. Ta-da, 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 and we have cursor. So shadow. I have like one really cool example scene here where I combine some of these. Maybe that's a good starting point for you. And I wanted to show it to you because it does look nice. It's a beautiful little ball in the ocean scene. And that combines some of the things. It also adds fog, something I haven't covered. Animations has an ocean component. So a couple more things. It also does look great in VR. So here it is for me to enjoy. Yeah, it is cool. I'm just looking at it right now. So all right, so this example also may be a good reference for you. So the URL is here, and I'm going to provide all these little references for you. So I'm going to show the cardboard template as the last thing because obviously, I mean, we will probably interact with our giraffe at some stage. I'm going to give it an environment component later. I'm just going to show you a few of the cardboard things so that we can do cardboard as well. So I'm going to get rid of the Oculus Rift. It was starting to get heavy anyway, and it also always does funny things to my hair, but that's just how it is. Cardboard. Okay, so template. Here's the template. If you wanted to get some of these things working in cardboard, then this is the template for that. Okay, I made it a really big VR button. It has a cursor, and that cursor fuses, and then I don't know whether I have interactions. I don't have any interactions. It just fuses on things that it hits. And I'm hiding the AR button, and I'm showing the VR button in large. And so you can go to this URL, which is /debug. So if I type this into my phone, I'm going to allow VR. If I type this into my phone, cdpnio enabling debug, and then vvo_ooj, which is going to take me a while, this would run in my cardboard. And it's also compatible with, let me see that I'm done here, also compatible with the Rift. It's kind of like, you can develop for the Rift and then also make sure that things are working. This having a cursor in Rift is a little unusual, so that's something to keep in mind. But the template does work, and I'm going to show you how this would work in cardboard. I'm going to press the VR button here, and oh yeah, we have to go into the debug. I forgot. So we're going to go into the debug mode, otherwise it won't do this VR button. And now pressing the VR button actually launches it in VR, and I close this and I can see it in VR. Has a fuse, but we don't actually have interactions yet, just have a cursor for now. So we can start looking at things. That is the cardboard template. It does actually have an animation for the cursor. I'm just like looking here at the code. So animation for the cursor, that's what we have. And then we don't actually have anything. Do we have an event set? I'm just looking, trying to hit this thing. Okay, I don't have the event set. So I could grab this cursor and I'm going to add that to my scene as well. So here is my project. I'm going to add that cursor. It should be inside my camera, so inside my head. That's something to keep in mind. And this cursor I would only use when it is a 3 degrees of freedom headset, so no controllers. And I could actually find that out with JavaScript. I'm just going to reload my example, and then now we have a cursor. It's in the camera, and it fuses on the object. And what I could do is that when you click this object, maybe we could do the spotlight on and off. Are we going to do that? Okay, we're going to do that. Okay, we're going to do that. This is the last thing I'm going to do. 38 minutes in. Okay, so you're still there? Okay, my bunny is starting to drink things. So let's say when we have we have an event set in here. No. I'm going to get the event set component, just so that I don't have to do too much JavaScript. And I'm just going to check, did I have event set in my final cheater? No, I have other things in there. So it seems like this is something I didn't want to do, but I'm just going to improvise here. All right, so we have event set somewhere in my CodePen examples as well. Let's just see that we find it. Go to my dashboard, event set component. This one, and that has the right URL. That's the one that I need. I'm going to explain in a second why this is something that I want right now. I'm going to add a cursor to, well, we have a cursor in the scene, cursor in here, and we can also have a cursor ray origin mouse in here. we can have both. This is good for debugging. And then I can click things directly, and then I'm gonna have, we have an animation, and I'm gonna have an event set. We're gonna have click, so that's my event, and then we're gonna do on click. We're gonna make it, we're gonna hide it, and actually, let's see whether this works. Okay, so reload, click, and that hides the giraffe, and now it's gone. Isn't that sad? So we are, what could be cool for our scene? So actually I wanted to do that spotlight on and off, so we can actually do target spot, and we can give it, or it's called D-light actually, not spot. It's not directional light, so it's just call it spot, since it's not a directional light anymore. And so now when we click this, okay, target is, let me see, this might be target like this, because we're not changing the property, but this, okay, ta-da. So we cannot switch it on anymore, but that's fine, okay? I mean, we continue actually making this also like on and off. Anyway, so what I wanted to show now is, okay, we have this, we have the cardboard thing in there. Also, I'm gonna just quickly get my CSS, so I have a really big cardboard button. It's just going to make things easier, so I'm going to do that. I'm going to add that to my little example here, and so I'm just going to make it compatible with cardboard. Also, by the way, I should show this. So you can click this directly, okay, or you can do fuse. So I'm just like waiting, and then that's the same thing. So this is why this is going to work with cardboard. And yes, so I'm going to add the CSS here, style, just that stuff. So then this is just going to make this button really big. Okay, now we're going to go to my basic project here in the camera on the phone. So I'm going to actually type in a different URL. So we're going to do HTTPS, okay, XR MOOC glitch me, so /VR/basic, then another slash, and that runs the scene, loads it. I have it here, it's quite cute already, and I'm going to put it in my cardboard and press the VR button, and it goes into VR, and I can now look around. I could also hide the shadow light, but anyway, the shadow camera, and then when I fuse, bing, light is off. Okay, we cannot turn it on, but that is fine. So we've done it. Basic VR with a little bit of interaction, cursor based. And the next one, the more immersive one, I'm going to do the actual VR controllers, okay? In the next episode, we're going to use these. All right, so that's it. A little bit of a walkthrough. Wasn't always very smooth when I wanted to transition to show you things, and then the Oculus viewer, so please forgive me. But yeah, I think in the next few lectures I'll be better. But the AR one is going to be a little tricky, so let's see how I'm going to do there. Hope this was useful, and I'm going to share the project with you. Didn't turn out to be the final thing yet, so we're going to do it in the immersive part. We're going to add teleport controls. I'm going to walk around a little bit, and that light, spotlight thing, maybe we're going to remove that. I don't know yet whether we're going to keep it. Let's see. Okay, see you in the next one. Welcome to this lecture on immersive VR experience. This is the second in a row of hands-on lectures. I'm going to use again primarily the Oculus Rift S, And at the end of this lecture, I'm also going to show how some of the things I talk about work in Cardboard, but we're actually going to go beyond what you can do with Cardboard. So I'll let you know. Okay, and so in the previous iteration, we were like here. So this is the scene that we had created, and it was already made for Cardboard. And then when you kind of like fuse on the object, and you hit it, then you will actually disable the light. So one thing I'm going to do is actually just reload this quickly and see that I'm going to disable the shadow camera so that we don't actually see it all the time. And so then it's kind of like more or less our final version. And now you can just look at the giraffe, and I'm going to disable this this ray origin mouse cursor. This is, I just do this for debugging, so that I can click objects, but now there's no click anymore, and I have to use the cursor, and I have to fuse on the giraffe, and this turns off the light. So that was what we had created before. But I actually told you where we want to be is more like here. So I have a new slide deck. Said want to be like here. So I'm going to play this again. So this is what I had in mind for us. I'm going to, in Firefox, the full screen, it works a little bit differently, but we're going to use Firefox again so that we can do things in VR very quickly. So I said I want to be here. I want to be able to actually look at the giraffe. I want to have a little bit of an environment. So we're going to add this environment in this segment. And we're going to have, well, we have the controllers. I think I showed you the controllers before, but we didn't have teleport. So, and then we added all the spotlight and all that kind of stuff. So let's see. I'm going to leave the spotlight where it is. So basically we completed this in the previous segment, and now we're going to go for, we're going to go for the immersive VR experiences. So environment, we're going to add physics, sound, maybe I would need to use animal sounds. I'm going to show you an example. I may not add everything to the scene. Definitely going to do an environment. Probably not going to do physics, but I'll show you examples of physics and the menu. And I'm going to also talk about how to get things working with Cardboard again. There is an A-frame speech component. We'll see whether I get that to work, and maybe I can show that one as well. So let's get started. So the first thing we want to do is get an environment. So here I have an environment component as an example scene with the environment. This one I made a really nice, actually a really nice winter. So we need to grab this script. That is our environment component. I'm going to go in here, and I'm going to just duplicate this as well, that was actually our basics. I'm gonna duplicate this and actually make it a immersive index HTML. So immersive index HTML. So we're gonna have that there, and that final one, we'll see. Maybe I can actually rename this into final index HTML. Let's see, that would be our final. That's what we're aiming for. So in this one, we're going to start from the previous one. So we have event set component in here. I said I'm going to get the teleport control, the environment actually. Sorry, not the teleport controls. We're going to do that later. And so let's see, let's load this in here. Actually, we're going to call this our immersive. Okay, it's going to be so much more immersive, haha. So let's see, we're going to get immersive to load here. Okay, still the same. I'm actually going to disable the cursor for now, because it's totally Cardboard and we don't need that right now, so no cursor. I'm also going to make that VR button a little bit smaller again. So that was a little bit, just like, you can do things like that to, obviously then it wouldn't apply anymore, and so that is the fast way to, that's what I often do. Anyway, so Okay, so we have a spotlight. All right. Said we're going to get an environment. So the A-frame environment component, so we're going to get an entity. We are going to actually remove this plane that we have here. And actually leave it. So I'll show you first what this looks like if we don't remove it. So I'm going to get a new entity. Okay, and that is going to be our environment. So and we're going to have preset forest. Okay, so in my example, this is a nicely decorated winter forest. So it has the A-frame. I already also comment out the plane here because it would lead to some flickering. I'm going to show you this in a second. And then I actually customized this quite a bit. We're going to get the shadow as well because I want to have the shadow, and sky color. Yeah, I'm going to leave it the way it is per default, but I'm going to get the shadow because I want our shadow to be there. So here is our, so then you will see we have a little bit of an issue here, right? So this is the plane. You can do two things. If you really want to keep the plane, then you move it up like just a little bit. So then you're telling the computer to really render it on top. And so now, because previously they were at the same Y, and that leads to issues. But I actually don't like it. So if you don't mind, I'm gonna just remove this because we have an environment now, and it's gonna look cooler. And we have the shadow there. For some reason, it stops at some stage. I do have shadow. The environment comes with its own ambient light, so I guess we can actually remove that. And I do want to keep our spotlight, so we don't need this in this light anymore. I would like to keep our spotlight, and I would like to see it. We saw it better before. Right now we don't actually see it so nicely, but that is okay. I think we can adjust the A-frame environment component. So in my template there is C here for details, I say. So let's go to this web page, and then we actually can find out more information about the environment component. Lots of different environments that you can have. Forest, really lots of interesting ones. I'm going to go for the forest because my giraffe belongs into a forest. So we can change the light position, ground color if you wanted to change a little bit. Sky type, we can have a gradient or an atmosphere. So the default is atmosphere. We could do a little bit of a gradient. What does it look like right now? This is a gradient actually, or atmosphere as they say. I'm kind of happy with this. It's cool. Lighting. Default is distant. Let's try point light. I wonder what this looks like. So in here, as part of the environment, you then just add here point. That's what they said. Does it change? It does change quite a bit. It's interesting. Now we have two shadows, right? Mine from before, and this point light must be coming from somewhere at a distance. So also has a little bit of fog. We just get that with the environment. So the environment does a lot. It adds quite a bit of stuff. Has a little bit of fog as well. We can even increase more fog or less fog. Do we want more fog? I don't think we should have too much fog. But since I'm not sure what do you think about the point light. Here is the environment light. Which one is this? Type. This is the point light. If we move this a little bit higher. Okay. I'm going to do that. I'm just going to take the point light that we have, and we're going to say light position, and we're going to adjust the light position to, I don't know, this roughly -124,055. So what does it say? I think it has light position of the main light. If sky type is only the orientation matters, otherwise okay. We're going to the light position, and then we're going to put it there. We're going to get rid of my spotlight, so because we get a light with the environment, it's fine. And we are going to have lighting point, light position, and we could actually have it where I had it before. Let's see what that looks like. I mean, I did like it much better the way I just looked at it in the inspector. Just remember this coordinate roughly. It's not too bad, but the original position, let's move it a little bit to the side, okay? So a little bit more, maybe a little bit more to the left. So let's do minus a little bit more to the left, so then we have the shadow on the right. I like that now. Hope you like it too. Okay, I'm done. I don't want to repeat too much of the lighting stuff we did before, but we have an environment. You see, we have an environment, we have light. So let's go into VR, get my Oculus viewer running. So show you this, put on the headset. And here we go, headset is going to be on. Okay, so we have the controllers, we have laser controls. We're going to do something more with the laser controls, and I'm also actually going to teleport, I think, fairly soon. But this looks pretty cool now, okay? So going to go back in here and just cancel this. Light position, all right. So we have the environment component. We can do a little bit of sound. I'm just going to show this very quickly. I'm going to get the background sound. In this example, I'll have a few things in here. One thing I have is when you click or when you hover things, but when you click, it actually starts playing a little bit of an atmospheric background sound. And I'm going to get that because that's what I want here. I'm going to put that in my assets, and then I'm going to actually copy that as well up there to trigger the sound. Sound is a little tricky sometimes, so just be like, it doesn't always work in every browser, it doesn't always play. That was a typo. Cool, that is my audio that I've previously uploaded. And we're just going to use that, but we need to trigger it. It doesn't autoplay, usually, at least not in all browsers. So here, what I'm doing is actually sound, just so you know. Okay, and it does say, there's a note here. It doesn't always work with the autoplay. They say it should do autoplay. Let's see, I don't think this works. So I'm going to get the sound added just to the scene. I'm going to reload this so I don't have that all the time. That sound in my head. So here, this is the part that I want. I definitely know that this works. Roll-off factor 0 means I'll hear it everywhere. Otherwise it would roll off from the location, which would be, the position would be, I guess, 0, 0, 0. Oops, we're going to do it like this. Volume not to, we're going to do the rainforest, which I have in here. That is the sound. So basically, when I go to this URL, that just shows you an MP3 player in the browser. Okay, and that is the thing that we're going to load into the background of my scene. I'm going to try autoplay true, but I doubt it'll work. I've had problems before, so let's see. If I reload, it does work actually. I get it immediately. But the trick is, if you have this problem, the trick is to just play it on click. So then when I load the scene, it doesn't actually do anything yet. But then as soon as I click, it plays. You can see the sound icon. I can make it a little bit louder for you. So now you hear a little bit more of the background. And so it's quite nice. But it is a little loud, isn't it? So I'm going to put this back so that it's not too loud for you. All right. So I have this in my head the whole time. And now, as we are entering VR, it is pretty cool. It did stop playing though. So that is interesting. Why did it stop? It should be looping. Roll-off factor 0. Let's just see. I think it had to do with me jumping into the headset. I don't actually hear it in the headset right now. So it's supposed to be playing, but for some reason it doesn't actually play in the headset. I'm pretty sure this has to do with my current Oculus thing, so I'm not going to try to fix it. I believe this will work some other stage. Alright, so where are we? We are going to put this there. So we have sound, physics. Yeah, I'm probably not going to do physics, but I wanted to show you physics. For physics I would need to do a little bit more, but here's an example scene doing physics. So yeah, I'm going to actually do debug through, so we see that the physics are here. So then it shows you how the physics are applied to this scene, and then as you're like moving this plane down there and you're like kicking, oops, this one fell, you can play with these objects. So this is my click drag example. It has a little bit of physics, and see, let's see, where's the ball? Hope it's going to come back at some stage, bouncy, bouncy, and then things will fall. Okay, so we have physics. Is more information on physics if you want. I mean, we could have a little bit of food coming down. Are we going to do this quickly? Okay, we're going to have some food, but I'm going to make it very basic, okay? So we're just going to take a sphere. I'm going to add physics to the scene, but just like, okay, very basic. I don't know what giraffes eat. Right now I'm blanking on what giraffes eat. We're going to have a really small dynamic body. One thing I need to get the plane back. So we're going to have physics. So let me copy paste that from, I have too many things open here now. So physics is, we need the physics A-frame click. So I want to have the physics system. Here is the example for the physics system, and then this is a way to do it. I feel like I have a more specific code pen, but let's see. This should work. I know there are a few different physics systems versions out there, so that's just why I'm wondering, but okay. So here's our scene. I'm going to organize things a little bit more. And cardboard template, we're going to get back to that later. I'm going to close a few things. This is our immersive preview. This is what I'm working on right now. Sound. This, we're done, we're done, we're done. Okay, cool. Now I can see things, all right? So, became a little twofold. So we need to get the physics in here. So I'm gonna get it like this, and for consistency reasons I am going to write the HTTPS just here. So I'm going to load the physics, and you can always see whether you're hitting the right script. So this should definitely still be there, but let's just see that it actually works. So it does load the JavaScript, so this is fine. And then we're gonna enable it on the scene. So physics, have to enable that. And then we're gonna put this at 2, let it fall down, maybe in front of the giraffe, so minus, I don't know, 4 maybe, and the radius should be pretty small. And I don't know, whatever it is, we're gonna make it green, okay? I don't know what it is supposed to look like. And so let's see what this looks like when we load the scene. Let me see. So the problem we have now, it'll just like fall down there. It's also still a little bit big for our giraffe. So, so I'll show you one more time. It is going to come, but then it's like flying through. I'm going to actually make this a little larger and green. And so the problem with that is we don't actually have anything for it to land on. I'm going to bring back that plane. And I'm actually going to move it below our environment. But I'm going to show you first actually above the environment, so it's easier for you. And I'm going to make this a static body. That is very important. So that way we're going to keep things on top of the plane. So now it's going to fall down there, bam, bam. And our giraffe will have something to eat. Very, very cool. And I'm going to now move it below the environment, so you won't see it, but it is actually still hitting the environment and the ball is there. I'm going to go into VR just to check where we are. Right now I'm going to get our Oculus viewer, full screen and mirror type. Okay, we have hand controls and we have, maybe we can pick up the food. Maybe that's what we're going to do. We'll see. Okay, so we are, okay, now I have the sound in my headset. It is really loud. I told you it's going to come back at some stage. Okay, one thing we could do is particle system. This is an interesting thing to make scenes more immersive. There are a few different particle systems. I'm going to show you some examples. This one is probably not something that would make a lot of sense in our scene right now. Stars. So there are different kinds of presets. Stars, dust. Gonna have rain? What do you think? We're gonna have rain. Okay, I'm definitely gonna do rain. Okay, we're gonna have a little bit of rain then. So gonna get the particle system, make it immersive, have a little bit of rain. So now I see what we're doing. Okay, cool. Here, I'm gonna make this even softer. I'm gonna remove the sound because it's pretty annoying for me. So I hope you don't mind. And yeah, that's fine. Cool. Particle system, right? And so we're gonna get the rain. We're gonna make it rain. So we're gonna have particle system, rain, heavy rain. Okay, we can think about that. Color should be, I don't know. Let's just see what the preset does. So is it gonna be sad? Oh. I remember the environment doesn't actually work very well with the particle system. Now that's sad, and it actually just died or something. Yeah, it just doesn't work. So I'll show you. So this we had this problem before, and I don't know why. But when I don't actually have, okay, it just looks like the velocity is like crazy. Let me see, I do want to have a little bit less rain, so let's go to the particle system, documentation. Didn't I have that open just a second ago? I don't know. Okay, here we go. Open it again. So there is a velocity value and direction is fine, duration. Okay, I'm gonna do velocity. The emitter base velocity. Let's see. So this, let's see whether this does anything. So if I make this, that looks like rain now. Okay, I see. Let's see. Yeah, okay. Fine. We're gonna have heavy rain. Otherwise it looks like dust. So we could have the rain. Okay. Poor little giraffe, rain. The problem then is it doesn't work with the environment. I still don't know exactly why they are incompatible, but as a proof of, so nothing views anymore, nothing works, and then we have a pretty much, we have an issue here, a shader error, and maybe that kills it. So maybe with a fog, so if I set the fog, I'm just going to try one thing. So I'm going to say fog to false and see whether that does anything, but I'm not sure. This would probably not. This fixes it. Oh my god, I'm a genius. Cool. So we have a little bit of rain, but we need to make the... Does it look like rain? I don't know. It doesn't really look like rain. It looks a little crazy, but we also have to make it a little bit darker, right? So we're going to change I mean, why not? So we got the environment fixed. We can't have fog and particle system for some reason, and light position, and then we can go back to the environment. So I'm gonna just look this up again. A-frame environment, component, cool. So here what I want to do now is actually have sky type, gradient, and if type color is gradient, is color or gradient, set the main sky. So sky horizon, okay. We're gonna make it a little bit off, so we're gonna have sky color, sky type, gradient, and then sky color. We're gonna have a little bit of gray, and then what was the other thing called? I forgot. Oops. Horizon color. Horizon color. Let's see. Sky blue. The other way around. And darker. Let's do gray. Gray is like a 666, so it's a bit darker. And overall, we're gonna make it a little bit darker. Okay, just like lighting, shadow. Do we have intensity? Can't have intensity. It seems so. Lighting distant. Maybe. No, I like the lighting. I'm not going to do too much lighting. Flat shading, no, we're going to do that. Yeah. I mean, the ambient light. If we do the ambient light, I'm just like, let's see. If I were to change things, and we can hit play here, so it plays even while we are like in there. The physics would actually, by the way, still work. You can see a little bit of the plane that we have underneath there. Anyway, it's our little giraffe, and it's raining, but it's still happy. I wanted to, what did I want to do? I wanted to light. I was thinking ambient light, so this is the point light, and this is the hemisphere light. And if we can get the intensity a little lower, it would look cool. Right? It would look so much. Well, it's a little dark now. Good. So light position. Maybe it does support light intensity. Let's just try this out. Maybe it's not documented. But no, it doesn't. So I'm gonna actually try the ambient light. So so here's our ambient light. Let's just bring this back, and we're gonna make it much intensity. See whether that makes the scene darker. Yeah, it's just gonna make the models darker. You can't have negative light, I guess, so can't make it darker. I could. I'm gonna live with this. So no rain then. What do you think? I mean, we can have more fog, but we can't have fog because of the environment. What if we do our own fog here? I'm just like curious if we have fog. Is it gonna die as well? It is still working. So then A-frame fog. Let's just look at that. So let's try something like this. We do our own fog. Let's do physics last. Let's see how that looks and whether it actually messes up things. Okay, and then linear, and then there is a what's it called? There is a distance near. We're gonna do near near far 8. I should make it pretty sad now. No, it doesn't work yet. I know. Why? Okay. So we do have fog, right? So when I zoom out, it doesn't actually do too much. So we do have fog. It didn't actually do it. So on the scene, particle system. I'm actually gonna make it a little bit darker. So, but I don't see the fog here. It should actually be there. And okay. Near and far. So this fog doesn't work. I'm gonna try remove the environment just to see. So the environment actually then plays tricks on us from time to time. So that's a bit sad. And now we have so much fog we can't even see the animal. Okay, so the fog really isn't working together with the environment. So I'll just give up on the fog. Good. Okay, I give up. Can be persuaded. Bring back our environment. Good. So we have rain, and that I showed you. So not everything, unfortunately, is working on the demo. I showed you particle system. We added that. We have teleport controls. So that is here. Teleport controls. We have the environment component already. I think I already added this script, but I'm just going to add it again to my here. Environment component, load, particle system, physics, teleport controls, immersive, right? Quite immersive, so you can see the number of components that we're adding. So then we have that, and so teleport controls. The way we're going to do it is we need hands. So we already have hands in the scene, I think. And we're going to get teleport controls. We're just going to add it to the left. I'm actually going to go for something like we did in the so here left teleport controls, and I'm just going to use hand controls instead of laser controls. And then here on the right in my laser controls, I'm going to have a laser controls. I'm going to make it raycaster. This is just going to work on objects on the giraffe. That's the only thing that it can hit. And a line, we're going to make the line red. Okay. And then the other one doesn't have anymore. We have teleport controls, and then we should be able to look at the giraffe, and actually probably the food. Okay, so let's try. Did I bring back the mirror? Or I still have it on my head. Post distortion, full screen, and running it in VR. And here we go. So laser controls and a hand. That looks weird, right? Yeah, we have a hand and we have laser controls. And we can touch the object. You can see how the laser is going, otherwise going through, like through some of these objects, but the giraffe, it actually hits, at least sometimes. Okay, there's a pretty accurate collider on the giraffe. I feel like, I mean, you can see it from the side. hitting the legs, hitting through the legs. So this is actually on the, it has a pretty good collider, so we can see that now with the laser controls. But we actually want to do teleporting, so we have teleporting on the left on grip. It looks weird, so I'm going to get rid of the hand. I wanted to show you the hand. I'm going to make it Oculus touch controls, so Oculus touch controls, so they look the same in a second. And just one has a laser, the other one not. But hand controls is something we can do. Alright. And so theoretically I should still be able to click the giraffe and hide the spotlight, but we don't have a spotlight anymore. So, since we don't have the spotlight anymore, that interaction isn't working anymore. So, this one is obsolete now. No more spotlight. I'm just going to remove that. Directional light, also not anymore. And instead, we also don't need another sky, actually. Well, nobody noticed, right? Didn't see that. Okay, and we are going to, actually we're going to do anything that is interactable, okay? Anything of class interactable, and then maybe we can have, if we had a giraffe sound, let's see, I'm just going to try, this is a bit experimental, so we're going to make it class interactable. When you click the giraffe, not sure what we're going to do, we're going to click the giraffe, but we're going to have this interactable and this interactable, also the food. And so then both should have a collider, so now when we go into VR, we should be able to intersect the food, cool, and the giraffe. So these are our two characters and we could do something with them now. And let's see what we're going to do with them. Okay, let's go a little bit more to my script. So you have teleportation. Yeah, on the left we have teleport controls. We're going to move the rig, so we have all that. Teleport origin is, and we're actually going to do the trigger button rather than the grip. So now this is just a different button, but it's a different, it changes the user experience for me. It doesn't look like different for you, but now when I use the left button here, I can kind of, I think we can change the resolution of the shadow, so because it does look a little pixelated. That's something we could do, but we have our giraffe, it's moving. And to be honest, if I get up, this giraffe isn't big enough. So it's like a baby giraffe. It's something I never really figured out before, so I'm going to actually make it larger. So, and the way we can do this, and I've previously played with this, I'm going to make it quite a bit, if you make it double the size, so that would make it quite a bit larger. And now we're pretty close, and I just want to make sure that when I okay, I closed the thing here again, sorry, that when I actually stand up, that I feel like I'm like not like eye height. This is good. Yeah. Okay, so if I were to whee! Tracking just went crazy for a second. So hello giraffe, we can look at you now. I want to do something with the food, but we're gonna grab it with super hands, and I'm gonna show you super hands. Okay, so now I'm okay with the height. Definitely, we could add more sound. I disabled the sound, remember, and we could also have sound when we click the giraffe and whatnot. But we wouldn't learn too much new stuff now if I showed that. So we've moved on already. We have teleport, laser controls. I have that already. I showed hand for a second, but I want to get to super hands. So super hands is pretty cool. So I have like a demo here of super hands. I'm going to disable VR in this scene, and I'm going to show you super hands. So if you go to super hands, there will be different objects here that I can interact with and pick up. So I'm going to actually just like I have really big hands here, and then I can interact with these objects, pick it up and scale it. It's just like we did in the zoo example, and then also throw it. Okay, so and all I want to accomplish now is pick up the food. That's what we're going to do. Okay. Oops. Yeah, I should not have done that, but okay, fine. Particle system, we are done. Teleportation, we are done. We're going to do super hand. So we're going to grab we have physics. We need physics extras for some reason. I forgot why, but this is what super hands would tell you. And so we're going to do these, but I already have the event set. So I'm going to add that to our library. Make sure that you don't add any scripts twice, so no event set twice. Otherwise, it's going to yell at you. Super hands. I'm just going to remove the version numbers here, because that way I just get the latest from unpackaged. So, okay, cool. Just make sure that this, again, resolves to... That does actually not work because I removed this. Okay, glad that I tested this, because I would have probably debugged this forever. And now we have the script. Okay, so that would be loading, and then we need to add it to. Okay, we have the script. We need to add this script. This is a phase shift, so we can pick up things with the collision forces. So that's just something I'm going to add. Okay, so before the scene, turn controller's physics presence on while button is held down. This is something that you can see in the super hands examples. They'll tell you to do this, installing this phase shift. And that's something we will need as well. Then we have preset physics here, a cube. And so the biggest thing is to add, I'm going to do just grabbable, because I want my food to be grabbable. So this green thing, it's going to be grabbable. This can actually have physics, dynamic, and shadow and all that, just grabbable. And I'm going to also do this when you touch inside. So hover on. We're also going to do hoverable to change the opacity. So we're going to just get that, but also hoverable. So when I pick up the food, so here hoverable, and then when I pick up the food, I'm going to have a little bit of the material changed. Going to have that class here so I remember it. And so I'm going to sort things a little bit. So we have that, then we have the hoverable event set stuff, so that changes that, and this is the previous stuff that we had. Okay, so what should happen now is that we will be able, when we get there, we will be able to pick it up, I think. I'm just double checking that I didn't forget anything. Oh yeah, we need to add physics to our hand. I'm going to tag this entire mix-in. This will, mix-ins just go in assets, and this will just work. And I just have to give my right hand the mix-in hand. And this is the cube, so we can pick them up. Plane, so that things don't fall. Hand controls both have the mix-in. Hand controls right, so we don't do laser controls anymore. Are we okay with that? I guess we are fine. So I showed a little bit of the colliders. We're going to do hand controls and hand controls actually. So hand controls so that they have hand controls, hand right, and there is actually hand controls is improved a little bit. So oh yeah, okay, that A-frame hand controls. That's what I want. So hand controls is a little bit improved recently, so you can have a higher poly model. So we're gonna do high poly. So high poly or tune. Depends which one you want. We're going to do high poly. It'll look a little better. And we're gonna make both hands controls now. I'm just gonna make one left and one right, and we can have a teleport coming out. Oops, that's the wrong thing. Left. Okay, so I feel like this is now my scene, and there's the food. I'm still somewhere in VR here, I think. So let me go into VR. I'm not saying anything anymore, just I always press it accidentally. We have hands, okay, and okay, I'm gonna go a little closer. This is really on the floor now, and I can pick it up and throw it, and now, oops, oh, it just fell off my plane. The plane below things isn't large enough. But let's just reload the scene. I can make the plane larger. Okay, so that things don't fall off anything unexpected anymore. The plane that is our static body, really make it really big. And this one doesn't even matter. Our plane doesn't have a depth, so we don't have color. Just make it black. Shadow, doesn't need to render shadow on it anymore, so we fixed all that, and so now things shouldn't just roll off anymore. So here we have it, our little giraffe. Oh, it's not so little anymore. Gonna teleport there, pick up the ball, which is the food, and I'm not even sure how to get it, but I can keep it with me. I can teleport with the food, and maybe I can actually throw it at the giraffe. Let's see whether it's going to pick it up. Oops. Yeah, the velocity wasn't great. And it's actually kind of rolling through the giraffe. We could add collision. It's still rolling. So it's still there. Anyway, that food is gone. I am sorry. But we made it a pretty immersive scene. I'm not sure what you think, but let's see where I am in my little script here. So what else do I want to show you? Maybe menus, actually. I did want to show you menus. Okay, so we did all this, and I have examples also for adding a heads-up display. So this one is also cool because it shows shadow. I'm just going to show that. I'm not going to add it to my scene. Here we stop. Oops, yeah, I couldn't, for some reason, couldn't stop it. Okay, we're going to start this. This is our heads-up display, and now I actually have a counter and a little bit of fog here, so that's also cool. And it doesn't have anything else this scene, but it has a text. I think it says game over, yeah. Has a text attached to the camera. And I obviously see this only once because stereoscopic rendering, so not twice, but you knew that, right? So. Okay, so that's a heads-up display, and then I have another example which is a menu, and this one I'm just gonna open. Here we have the menu. One thing I have to do is the menu should be hidden per default. I just had it visible, so the menu is here visible so that I can show things in the screenshot, but this is how we should run it. So now it is there. And so the way this menu works is you have controllers, and you bring up, well, you can teleport, and then you can bring up the menu. The menu is actually attached to the camera, and you can just collide through them to hide and show these objects, okay? So show and hide the box, and when you release the button, it'll go again. I've tried out many different menu designs. It's not great. This is one that is relatively easy to implement, and it's attached to the camera. Obviously this is a heads-up display menu, if you will, and you can actually really go through each of these and show them all or hide them all. So that's maybe one cool way to, in terms of how you can interact with it. Obviously we could also have you kind of I had a version where I had a mini mini thing in my controllers. I showed you many different kinds of menu designs in my lecture, so I'll just leave that. This is a HUD menu. I do have another menu. Let me see. I want to show you the other menu. Yeah. Just go to my profile, I think. Actually, dashboard. I never know which one is which. And here I should have another menu. I feel like I coded a controller menu. Yeah, let's do the controller menu. You will find many more examples in my CodePen library. So let's see, and I closed it things again. Michael, full screen. So, and here I have a, okay, let me teleport back. What I like, I have like a mini version of, this is like a miniature world. And it's kind of cool because it's like attached to the controller. Okay, the controller is black, so you don't see it so well, I agree. Easy to change the background color. But it has this, it's the same functionality, but now the menu is attached to the controller. And this one I actually like. The HUD menu, didn't like so much. But I showed all the different kinds of menus, including hand menus. But hand menus won't work right now. This is a Rift, not a Quest. Right now, no hand tracking in the Rift S. And so, yeah, that's that. So, let me see. What else? Oh, yeah. I'm going to show you one thing where you put everything together. VR Tron Primitives is my little fun game. For that one, I have to actually get up. This is my example where I really put lots of things together, including all the sound and all that. So, okay. I'm going to make this a little bit softer. Just afraid. Okay, so here we go. Oop. I closed it again. Don't yell at me. Yep. So, cool. This one has a lot of the things combined. It has light in my helmet. It has a shield right now, and I can place a cube, and then it falls. And so this is how this works. And then I can change my functionality to shooting. And so then I shoot these objects and they disappear. Okay. I can also place new ones, and I can use the shield to shoot these objects at different people. So the idea is to have a little bit of a game here. Obviously, that's what I was aiming for. So, but interestingly, when you teleport, you can have the shield, but when you shoot, like when you're placing new cubes, when you're shooting at cubes, and you could get points for that, then you can't have a shield, so no more shield. When you place things, you can have a shield. So you can quickly switch between these different modes, and I'm going to teleport a little bit so that you see what's going on, and I'm going to go into the shoot mode, and now I can shoot all these objects, and they will disappear, and that's pretty fun. So a little bit of a demo here, and the sound is pretty loud, I think, but that's just how it is. So shoot, shoot, shoot. Okay. And the mode was visible in the HUD, and so that is that. So these are a lot of things I wanted to show you. There's more. I have many more examples. Check out my CodePen. And we are kind of like at the end of this lecture. A little bit longer than I wanted it to be, but so one thing, cardboard. Okay, so I'm going to show you two things with cardboard. One thing you can do is actually travel with cardboard. Coming back to the cardboard template here. So this is a cardboard template I showed you previously, and here I show you a VR gaze travel. Okay, so I'm going to run that scene quickly here in Firefox. So when I look at this, it does gaze-based travel. So I can also run it in VR, just have to stop Tron, run this in VR, put on my headset, get the mirror one last time, and put the headset on, what is important is that you no controllers, okay? No controllers because we're simulating cardboard here. So headset is on, and now it's gaze-based travel, so I can look at these teleportation points and then they take me there. And now, okay, I'm gonna look at the blue one and I'm gonna jump to the blue one, and now I'm in front of the blue one. Yellow, you get the idea. And I can travel back as well. So that's gaze-based travel, and so shooting and stuff could be done. Oh, I killed the headset again. Shooting could be done potentially with a button, but you need to be able to shoot at something. So you could obviously with the cursor and then shoot objects like my cubes. We could implement that on click with the button, so that would work. You can probably get most of the Tron stuff to work, but you cannot switch the modes. Like we needed 2 buttons for travel, for switching, for shooting, actually 2 controllers. So it would be hard to actually implement Tron primitives, which is obviously a very simple game. It would be hard to implement that for cardboard. But I wanted to show you that a lot of this is possible. I hope you enjoyed this lecture. We definitely made the scene a bit more immersive. So let's just check one last time. What did we actually create in the end? I'm going to open this scene in a new window. I'm going to actually add the Immersive VR as our example down there. So Immersive, wow. Immersive VR is our example scene, and I'm going to open this in a new tab, making sure that none of these are running in VR. And let's we have a little bit of rain. Yeah, so here's our scene. We see our cool giraffe. I'm going to get up for this demonstration. We have hand controls. It's pretty immersive. We have a little bit of an environment. We can teleport and we can pick up this food. Oops, no, I'm pretty close. Pick up the food, have it, can travel with it and see whether the giraffe would like it or not. It doesn't seem to care. And we could add more interactions as well. But this is still pretty fun. So, a little bit of a fun lecture on immersive VR. That was about 50 minutes of coding. I think we've seen quite a bit, and hope you enjoyed it. Next one is AR, so I'll see you in the AR ones. I have one on marker-based AR and one on marker-less AR with WebXR, aka A-Frame and A-Frame AR.js. In this video, I'm going to go over some of the steps as part of our honors track exercises in which we're going to create a virtual reality scene. So the starting point is still the 3D scene from the last module, so really that was important. Obviously, you will potentially make refinements and definitely adaptations of that 3D scene as you're entering the VR space, but I would recommend that you first complete the 3D exercise following my method, and then you're taking on this one, even though you might be very eager and can't wait to make it into VR. I understand. It is a fascinating world. For this exercise, you do need some equipment, so you will be able to get away with cardboard and your phone, like a phone goes inside, so that would be a way to do it. I wanted to make sure that the vast majority of learners can at least do this. So that means that some of the steps in the exercise I mark as optional. They may not be feasible if you only have 3 degrees of freedom. Obviously, if you are a lucky one and have something like this, or even more modern than what I have here, I mean, right now this is the latest, the Rift S, and I have the Quest as well in the background. So then you can do quite a bit more. And if you're in that league of devices, then you can consider working with Unity or Unreal. And if you are cardboard, most of my students in my class work with cardboard, so in my residential program, and we can create cool things that way too. And you can notice, I'll come back to this idea, but we've cut out this part so you can also do augmented reality with the cardboard. And I'll talk about this when we're doing the AR exercises. So you can do this, even if you don't have some of the other devices. And you could even just, well, I do think it would be great if you were actually to see it in VR. So a stereoscopic view, I think, makes the difference. So that would be a good way to go about it. And you should aim for that. If you don't have VR equipment at all, you will be able to simulate things in 360. So it's like you're looking into the scene, and it's like a little bit of a magic window. It just doesn't have 6 degrees of freedom. It's just like you rotating around a spot. That is 360, okay? So that's not virtual reality. So don't confuse those. I do mean 3D virtual reality, and stereoscopic view would be ideal. So you have it on your head. You should mount it on your head. That would be the goal, but again, if you don't have access to some of the equipment, we will accept you doing a demo video or taking a few screenshots with running it on the phone, on the phone, I guess, would be the way to do it then. So here I have the task description. So this is your VR scene. Create a virtual reality scene in A-Frame or Unity or Unreal. Please refer to my first steps in each of these to get a better sense for how you would do it. I mean, by this point, you should have made your choice because you did a 3D scene already, or you should definitely have done the 3D scene. And so I'm assuming you have that 3D scene. And so from that 3D scene, what you would now do is, as a first step, is actually add a camera rig to the 3D scene. So an XR camera or a camera rig in A-Frame, so XR camera in Unity when you're using the the VR plugin. And the goal would be to view it in VR, which obviously requires a virtual reality headset. And as you're viewing it in VR, it'll allow you to make adaptations because scale is most likely not going to work. So adapt the 3D scene for virtual reality. Think about scale. You most likely have to scale things up rather than down, just to get the proportions right, especially as you're standing up. And if you're having like a 6 degrees of freedom headset, so you're fully tracked in 3D space, and you're getting up, like in my example with a giraffe that I showed earlier, you really want to get the scale right. You also want to get the layout and think about that, whether that needs to be adapted. How much travel do you want? How big should the virtual reality be? I mean, you maybe feel like, wow, now we have more space. Even if that's the funny thing. Even if you're just looking at your smartphone, let's say in 3D, and then you're putting it in here, you feel like, wow, I suddenly have so much space. But if you think about it, it's still the same screen, right? It's not more space. It's just like the way we perceive things. And obviously, having this agency around your head really makes you feel like, oh wow, now I really can do something with this scale. The user is like, think about some visual cues to guide users where they should look. And so let's go back to the exercise. So make it more immersive then. I would like you to really add an environment or terrain. You can do rocks and trees and everything in Unity, in Unreal. You can do that as well. It'll look amazing. It'll take you a little bit of time, but it'll look amazing. And if you enjoy this, why don't you just go for this? And in A-Frame, you can use an environment component and configure it in different ways. That would be the easiest way to do it. You could also go there and work with templates in A-Frame. So those could be copy-pasted. Basically instantiated at different locations, but you could use templates to create, for example, little forest areas or something like that, if you wanted to do your own little trees or compositions of 3D models. Lights and sounds are very, very important, and they will make it a lot more immersive, so please consider adding additional lights and definitely also sound. Optionally, you should support travel. This is a virtual reality world, and you can do this via a menu. Now this will require a little bit of digging into Unity and A-Frame. In A-Frame, yes, so there are no standard widgets. In Unity you have the canvas, either the canvas approach or you're using a widget libraries. So Steam VR has examples. The Mixed Reality Toolkit has examples. XR Interactions is using, in AR Foundation I've seen standard examples of just using the canvas. I haven't, have I seen VR menus in XR Interaction? Maybe they have that, I'm not sure. It's something for you to figure out. So XR Interaction is native to Unity. And then the other toolkits I just mentioned, they would be very popular platforms. They allow you to do menus. You will find examples, teleportation. So they have teleportation, hotspots, and areas, all of these toolkits. And A-Frame would have a teleportation component. So that would be actually relatively easy, but you need a controller. You need a VR headset and a controller. So that's why I make it optional. And then also object manipulation. And you can think about near and far manipulation as I showed in my exercises. And each of these toolkits have examples for this. And so it would be a great way for you to explore this. In A-Frame, it would require obviously ray casting. You can use the laser controls and respond to click events. I'll talk about that. So as I said, I'll provide more tips and tricks for A-Frame, just because I think it is potentially the one platform that a lot of us can easily access over the web, and since we're learning online and we don't have to download Unity and all that in parallel. But obviously Unity and Unreal will lead to excellent results, and it just requires a lot more time, a good bandwidth. So the amount of hours I spend downloading things in Unreal is amazing, but it usually looks great afterwards, and just creating a relatively simple project is several hundred megabytes, and then the one I'll show at the end of this course, Mission AR, is only 13 gigabytes. So that is a lot. That is a lot. So, yeah, object manipulation would be cool too. And so the whole idea of this exercise is obviously, I'll push you, because I want you, if you follow this approach, I want you to, you will explore actually a systematic method to create a VR scene that includes all the basics. So it's immersive, supports travel and supports object manipulation. And if you have a menu or manipulation, you also have selection. So we have all the basic ingredients that I talked about in the lectures. Overall, you will definitely develop a better sense for scale and perspective in VR. So that's something that will just happen. You need to adapt from your 3D scene, I'm pretty sure. You will learn how to create a VR experience in layers. So really, I would like you, as you make it more immersive, you would probably think about parallax. And so things should happen in the distance, in the background, in the midground, and the foreground. And don't just design the foreground. Really, design in layers. Just like Disney movies are composed in layers, it's going to make a big difference. So at least have a skybox, maybe something in the distance. Maybe have a few birds or something in there, just like something in the mid to background in addition to the foreground. Support interactions for travel, object selection and manipulation. That would be like, if you have all that, that means you have a virtual reality. You can walk in there, you can explore things, you can pick up things, you can manipulate things. So that's potentially what you would want. And yeah, the one thing I would say at this stage, usually my students are like super excited and they want to create a super cool game or something. It's going to be very difficult. And the problem with games is that usually you spend ages figuring out game mechanics and those kinds of things. So, I mean, if you have a game idea in mind, focus on one or two interactions and that's it. So no need to do this whole game here, although it would obviously push the envelope quite a bit. But yeah, no need, okay? So I wanted to say that. And I wanted to come back to our case study. So obviously our case study was a great example of a very complex virtual reality. So my student Kara, she actually spent hours building this. So don't be tricked. Even though this may not look like a Disney production, it's not. So in terms of quality, this is actually relatively high quality for A-Frame. We could have tweaked a lot more. Kara said herself she would have liked to do this or that, but overall it's a cool experience. It's a zoo, and we have travel here, so I can go to these different areas, also plan it out. I started with primitives. This whole scene started with primitives. So the 3D scene was the first step, and now we have travel, and we can then also do object selection and manipulation, which we implemented in this petting area, and you can feed the animals virtually. So this is only possible in virtual reality. I told you the zoo is modeled after the Detroit Zoo, but only superficially modeled, and the values of the Detroit Zoo dictate that animal welfare is the most important part, and so you don't actually get that close to animals normally, but in virtual reality we can implement that. You see quite an advanced scene, so this is several hours of hard work of a student who has previously completed my course, so keep that in mind. And here we now actually finally grab a banana. Come on, let's grab the banana, and I need to go to the other side and feed the animal. So this is object manipulation with super hands and A-frame, something I'll talk about as well later how to do this, as I'll tell you about immersive VR experiences. So that brings me to this overview of XR experiences, and so I laid this out previously in some other parts of the XR MOOC. So when we're talking about XR experiences, we have all these kinds of content, and we should distinguish between explicit interactions and implicit interactions. And so a basic VR experience, which is really just the goal here, would entail a 3D model, maybe multiple 3D models, and maybe animations, lights and shadows, which you get for free initially, but you should consider adding additional lights and also playing with shadow. And if you're talking cardboard, so here, a common way to interact is have a cursor in the middle of the screen, and that way would be a common way to point and navigate. So that's a cursor. So that's a basic VR experience, and then as we make this transition into an immersive VR experience, you can see there's actually quite a lot more things going on. So I do think a fully immersive VR experience includes all these things here on the left: an environment, physics, ideally, spatial sound, very important to make it immersive, and menus and HUDs as you're creating more, so heads-up displays as you're creating more complex environments. And so immersive VR experiences usually have these. You don't have to necessarily have that as you're increasing immersiveness. So this would be way of increasing immersiveness. And then also the interactions are a lot more interactions with a controller or a hand in VR, or speech and voice. And so you can prototype speech and voice interactions with some of the toolkits, but it's not a big thing. Usually you add additional libraries. So in A-frame, there's a speech component which uses speech recognition, so that's kind of okay, but you often have to repeat yourself. And maybe I'll include an example of that, but it's definitely in my CodePen library somewhere. And then controller and hand interactions are really, really popular when it comes to immersive VR experiences. So the majority of interactions, however, are controller-based. So usually with one or two controllers, and you provide support for the different buttons, the trigger button, the grip button. And obviously it depends on what kind of VR hardware you are using, and whether you have one or two controllers, and whether it's 3 degrees of freedom or 6 degrees of freedom controllers. On cardboard, keep in mind that you can do interactions. You have a button here, but you can also do explicit interactions like dwelling. So that means like fuse. You trigger the fuse interaction as you like hold onto an object. That is an explicit interaction, and so that would count. And even with cardboard, you can create immersive VR experiences. Don't think of basic is just cardboard and immersive is some of these advanced headsets. No, you can put in the energy. You do need an okay smartphone for the cardboard if you wanted to do something with particle systems. And that would be required. So you might be limited a little bit in terms of hardware, and that's fine. That's why a lot of these steps are actually optional, and just to show you what you could do to really make it an immersive VR experience. And so I hope you learn a lot. Again, you can choose the tools, so WebXR, Unity, or Unreal are all in for you to be used, and you probably have made your choice as you did the 3D scene. But if you feel like, hey, I want to try a different tool, maybe do that first. I wouldn't recommend, if you want to complete this quickly, I wouldn't recommend trying out different topics or different 3D scene. However, I must tell you that My students in my residential class, they usually do everything with both Unity and A-Frame, and we are also going to add more stuff about Unreal in my course. And while it may feel a little repetitive, I, from my perspective, see a lot of cool variety, and it's when the same scene is done with the same tools, it's very interesting for me to see the differences. So I find that kind of parallel prototyping, I find that fascinating. You can really see the differences between some of these scenes. In any case, it depends. Obviously, I'd like you to stick around and push yourselves and learn a lot more about VR than just making it quickly through the exercises. But if you want to complete it this week, then keep it simple and treat it as a starting point. Maybe something you can iterate on afterwards. Next module would be, so the next part of the honors track would be focused on AR already. I won't push you any further as part of the VR portion here, but we're going to look at AR as well, and that's going to be interesting and challenging, and but that should complete the picture. That way you have a good overview. So good luck, and I look forward to seeing things submitted to the gallery and the forums. If you have questions here and there, don't hesitate to reach out. Also, don't forget, at the end there will be a peer review, so get these materials in shape. Think about, what will you submit? Is this the thing? Is this the VR scene? Are you proud of it? Do you think you'll get good feedback? Anyway, the tone will be fair and constructive and nice. I really want to make sure that you're getting good feedback and helpful feedback, and so we want to be nice to each other. So don't be too hard. Don't go too hard on each other. And so good luck. And I'll see you in the lectures again, but also in the next module of the honors track, hopefully.
All right, hello everybody. Here we are. Welcome to our second office hour in the XMOOC. I'm Michael Ebeling, and I am the instructor in the course. I'm also a professor at the University of Michigan, and I'm just gonna start our office hour here. As in the last one, I have a few things prepared, and but also wanted to leave more time for questions. So the last office hour was focused on A-Frame. We did both AR and VR in A-Frame, and kind of like had a good overview. So we were doing a solar system that I was doing in the second course. I was taking it basically into A-Frame through various stages, and then added some interactivity. A bit of a 3D model was just a tiny lunar module for landing on the moon, and then it had like all these different kinds of. Did I have a link in here? I thought I had a link in here. It looked like this in the end. So so today we're going to do Unity. There was an error starting the editor. That is interesting. Let me just quickly log in. I guess I haven't prepared this A-Frame part anymore, but it should just take me there nonetheless. So I'll show you what we had in, that's my other course. What we had in the last office hour, roughly. It was like a starting point that looked a little boring. And then I created a new version, a V2, and then we had an index 3D HTML, for example. And I did it in VR and in AR and so forth. It just doesn't seem to load any textures at the moment. That is a bit sad. Wonder what's going on here. So, well, rather than, so I showed how to do all the textures and debugging and all that, and it actually looked like this. As you can see here on the right. So it was blue background, faded, we had Earth going around the sun, and we had moon going around the Earth. So, so that was what I did last time. So let's jump into today's office hours. So this is the second of a series of 3 office hours in this XMOOC that I'm doing this semester at least.
This one is focused on virtual reality with Unity. And so the office hours, I mean, we are allowed to ask any questions, and we can talk about everything in about, I would say, 35, 40 minutes. Maybe more like 35. Don't have so much prepared today. I can always show more. You're allowed to talk about any course, but I'll focus for my content here. I'll focus on the third course. That is the course focused on development. It is like all the other courses structured into 4 weeks, and it has an honors track, and we'll focus on assignments in the honors track. And for this office hour today specifically, we just focus on the VR assignment. And then I have another one in Unity on AR in a couple of weeks. And yeah, so this is where we are. Basically the second one of 3 planned for this semester. So let's jump right into Unity. The first thing, so these office hours, I usually come with a few tips, but basically I want to get you ready to work on the assignments. And we're just going to make sure that maybe everybody else is muted unless there are questions. And I'm just going to make sure that that's the case. Although I'm not a host, so I can't do that. So Angela, you need to help with this. We have a few participants that are currently not muted. And and I'll ask for questions later and just go through this first part first. So we'll have Unity here. When I took the screenshot, which is like, well, actually, the screenshot is probably not from too long ago, but I set everything up on my computer in December. And so right now, Unity Hub I'm currently in the beta channel of Unity Hub. So it has this black look. Maybe it looks gray for you, depending on which version of Unity Hub you're using. So we're using Unity Hub to manage different kinds of Unity installations. I was using the latest long-term support LTS version at the time. But if I wanted to install a new editor right now, it would be 2023 30F1. So I'm working with 26F1, but I don't think I'm doing anything where that you would see any differences. What I'm not doing is working with 2022, which is a pre-release beta. And I'm also not working with any 2021 versions. I'm still stuck in 2020. And that's fine for the purposes of our course and the purposes of the assignment. And I do this because some of the toolkits that I'm using for the VR and AR portions in Unity, they just have the best support they're currently tested with these versions, and they recommend you to use the long-term LTS, long-term support versions. And then what I usually do, I'm not going to stand here and now install for you, but there's actually video of me installing things. Associated with the office hour, I'm also releasing a number of YouTube videos. I give the link at the end, or I can actually just post it right now. I can post it into the channel. So these here. So this is our YouTube playlist, and I'm just going to post that in the channel, in the Zoom chat. So what I cover here is basically I'm taking video, I'm showing you what is in. So I'm going through my assignments today, and I'll link you to what's in the YouTube playlist. But this is something that you should do in your own time. I'm not going to do it. I'm not going to play these videos now. It's not just a YouTube playlist. But basically, I also add the second office hours. I added the one from last week. So the second office hours this week today, I'll probably insert right here before the Unity portion starts. And then I have quite a few videos on how to do things in Unity. And these are meant to be so that I can be there with you if you work on the assignments, and it feels like you can follow more along. These are not videos that I cut in any way. So it really takes 30 minutes to deploy things to a headset. It's real time. But for the office hours, that would not be productive. So I wanted to show you quickly what I install when I get my Unity ready. So when I do a new Unity installation, I'll choose the Studio, the Microsoft Visual Studio Community Edition. And then I usually do Android build support, and I need both. You need to select everything here. So the Android SDK, the NDK, and the OpenJDK. And I need this because I want to deploy to my Quest 2, and the Quest 2 is an Android-based virtual reality headset. And so if you have a Rift S, so which is already connected to a computer, like this one is black, and then you do not need to install the build support. But if you want to deploy to a headset like the Quest 2, it's Android based. You need all this stuff. And so this is actually quite heavy in terms of installation. It's almost 2 gigabytes that you just need to install. So I have all that for my current install. And then I'm going to just do quickly a new project in this version. And so when I start a new project, I usually just start from the 3D template. There are, except for when I do an AR foundation project. So when I do an AR foundation project, so AR next week, next office hour in 2 weeks, I think, that's the only time I actually choose a template that is not 3D. So I would choose the AR template. And so for any new project in the VR space, I usually start from the 3D template, even though you're tempted to say, yeah, my office hour project. Yeah, I'm doing a VR project, therefore I should choose the VR template. But I'm not necessarily using all the Unity stuff. I'm actually not even sure what the, yeah, this is opening in the background. I'm just like going to try one more time. I'm not going to actually select it, but just like curious what they actually put in there. It's probably XR Interaction Toolkit, maybe. No, it's just, you could actually technically start from this, to be honest. There's nothing wrong in here. There's nothing wrong in there that would actually make it not a good starting point. But yeah. Okay, so this is, I mean, at least from the package list, it looks like there's nothing wrong in there. So I'm opening the Unity editor in the background. I'm just jumping back to my slides. Here is actually my new Unity project. So what I'm not doing now is clicking around, like, I mean, not doing too much. So in the example scene that I'll create, I'll put a cube roughly maybe a little bit away from the camera. So the camera is, oops, then we should do it along the Z-axis. The camera is there, and right. So Z and Y up. Okay. So it's interesting. Working in these different tools, they always have different coordinate systems, right-handed versus left-handed. And then Unreal Engine is like the Z-axis is up rather than the Y-axis. So it's this, and sometimes when I switch between them, it needs like just 1 second to get calibrated to them again. But anyway, so in some of the examples, what I actually create the whole solar system in my videos. So I'll play some of it, but basically it's basic 3D operations, transforms, putting things together. And I'll show you the project in a second. So this would be my new kind of like my new project. And in order, so when you press play now, it's just a 3D project. You're just looking at it like that. It's nothing special. And then if I were to use the VR template, I could actually connect my headset and use Oculus Link, which used to be called Oculus Link, and to turn this into a display, which would be just like a Rift S connected to the computer. So the rendering is done by the computer, not on the headset anymore, but it needs to be tethered. So you can see there's this cable here. So once I use Oculus Link and I make it a VR project and I press the play button, I can actually play it on the device. And it's actually a very comfortable way of working through this. So let's win a little bit of time by just like going through some of the things. So what I show you in some of the videos in the office hour is really like putting together a scene and working with the game view and the scene view and explaining all the panels in Unity if you haven't actually used Unity before, showing you how to create a layout that I'm using in a lot of my videos. And it just allows me to have all the windows visible for learners. So when I record videos. So normally this is not even my layout. My layout looks like this. It has the build settings here, the project settings, the package manager, because I do a lot of things to get this up to speed and install all the packages. So there's more stuff in, there's basically a walking through the editor in the YouTube playlist, and that's something that if you haven't done a lot of Unity before, it could be helpful. So then, all right, so now let's get started on the first part of the assignment. I quickly do the 3D scene, just walk through, but I want to focus on VR. I think a lot of troubleshooting will be in the VR space, including what kinds of headsets to use, and I'm wondering what kinds of questions you have after this. But the first assignment in the third course, the first honors track assignment, is creating a 3D scene. You would start from like a sketch, or it functions like a template, something that you want to design. For me, it was the solar system. I created this solar system in the second course, and so I'll continue from there. The 3D scene, which is the assignment before the VR assignment, but it makes sense to spend a little bit of time on this, even though this is the office hour focused on VR. In the 3D scene, you would quickly sketch what you plan to recreate in 3D. So usually it's a good idea to base it on something existing, so you can measure and compare. How did you do compared to the template that you had? And so in my residential course, we were just going through this assignment again with my learners. There are also online learners currently. We are doing hybrid learning at the moment at the University of Michigan. So some students come in and some students stay remote. And I saw the most fascinating camping scenes, and some of their scenes were based on movies like Inception, and just really inspirational and actually really cool recreations. Obviously, when you work in this space, you want to probably do your own ideas, not just recreate things. But for practicing, I think it's always good to start from an example, and so to set a goal for yourself. Anyway, that's how the assignments are structured. Then we prototype a 3D scene with 2 to 3 primitives, so just basic shapes, add materials or replace some of them with 3D models to increase the level of fidelity, the look. And then I usually in the 3D assignment, I just want people to try out a few different camera perspectives just to get a sense for 3D. And actually, so that could mean that you fly around in the Unity editor, but it could also mean that you actually really insert a couple of different cameras and activate and deactivate some of them. So here is my solar system that I created. And so trying out a few different camera perspectives could be like, okay, right now, I think I have the camera roughly here, so it shows where the camera is. What if I started more like from the side view or from further away? We would probably be above the 0. So I fly around with the right clicking in the scene, and then WASD, just like in most games, I guess. And so I could also like take a side angle on this further away, or like what I really like is actually zoomed in. So it could be interesting to find a really nice perspective where you have like just like very zoomed in, like something like this. So anyway, that was the 3D assignment. And then when you're like happy with this position, you could copy it, copy this transform and just like put it in there, oops, that's the transform of the camera. So the current camera position, actually not sure how I would copy the current camera position. Is there actually an option to copy position? That would just copy the position that is entered in here. What I want now is the position of my current virtual camera. Anyway, I would then approximate it roughly, I guess, get it into this position, just like trying to get it here a little bit to the right and a little bit of rotation around the Y, like something like that. And because I have the game view on the right, I can always see roughly what it looks like when I actually started. And then when I started, it looks like this. And I added very simple rotations here. So it's just a very simple rotation script. And in fact, what it does, it rotates the sun, and the Earth is embedded in the sun. And it's interesting that the Earth casts a shadow on the moon, so probably didn't get some of the lighting right. I think I should have worked with a point light in the sun rather than a directional light. I still have a directional light coming from somewhere else, which is just the default light. But then essentially it does rotate the planets themselves, and then because the moon is nested in the Earth, I'll show that in a second in the hierarchy, it should just like appear, should just like come around. It's probably going to be pretty dark, but let's see what this looks like. Anyway, and I made it very slow. I can make it a lot faster too, so I did a little rotation script, but I guess I'm just too captured by the scene, therefore I'm waiting. Okay, come on, where's the moon? It's not there yet. Oh, we've waited so long. It's just like, it's probably right behind. Also, and because I'm not using any other toolkits at the moment, oh, there it is, finally coming. I'm not using any other toolkits at the moment. I cannot actually like, I don't have a camera that is movable, and I cannot fly around while I'm in the game view. But here is our moon. And but I'm going to make it I'm going to set up an MRTK project. A mixed reality toolkit project is the toolkit that I would recommend. So anyway, we've done the 3D assignment now, and it was based on what I did in the last office hour. So my inspiration was this NASA solar system here that I'm going to post for you. You can also play with it very quickly. It's actually really cool. Like it's obviously in a web browser, but like you can zoom in and you can like tilt around, and it has like this kind of like orbital system, and you could double click the sun, and then it would show you this kind of like close-up view, and you can go back and you can pick Earth. So Earth is like somewhere in the orbit there. Yeah. And then we can just like jump onto Earth. And the way they do it is pretty fascinating. It's obviously rendered very nicely. And I'm not sure how real time it is, but the ISS has this orbit around Earth apparently. And I'm not sure whether these ever update or whether it reacts to the current day. I mean, it does show current day and time, so I guess this makes sense if you think about where we are and just like waking up in some parts of the US, I guess. All right, so this is my inspiration. And so in the second course, where I focus on a lot of like prototyping, I did all this prototyping stuff, and I did a critique, and that was at the time still Google Expeditions, which is discontinued, and I don't actually have a very good replacement for Google Expeditions. So I was working on an update to the course instructions, and I put together a few apps that I found. There are some companies who try to be like Google Expeditions, but then they charge you money. Google Expeditions used to be a free mobile app that has really nice 3D experiences of existing places on Earth, or like some museums or like an airport, and then also some more educational ones like on anatomy or like the solar system. Anyway, in the second course, the focus of the second course is on user experience design. Some of you may be in that course, so maybe that is currently what you're working on, and maybe where you have some questions, so I'm happy to help there as well. Anyway, then in the second course, I already show like a few techniques, like working with the 360 grid and like Play-Doh to really model the solar system. And there are some elements in this video where I also then use AR in combination. So this is now an AR capture. It's actually a photo that I placed in AR. So then I can use my phone to view some of the content, and then I can actually use physical objects that I don't have to hold everything in the physical world. I can just anchor some things in AR. And so it becomes a very flexible way of prototyping. And I'm actually always happy with how well these methods are received. I mean, some of these things are coming from my own research, and I created some of my own prototyping tools that I don't maintain. It's very expensive because I don't run a company. It would be expensive maintaining them. So I also use a lot of existing standard tools with all their limitations that I try to solve in my research. Here, for example, you can see me use Google Blocks, which is probably also discontinued at this point. Tilt Brush is also did. But so these were some of the immersive authoring tools. Anyway, then for the 3D assignment, I have my sketch. I have a couple of ideas that I wanted to create, and I spent a bit more time on this in the first office hour. So I'm still working on the same project. I'm just like assuming, so last office hour was focused on A-frame, which is one of the paths through the third course. But now I want to focus on Unity, which is working with a cross device kind of like platform. And Unity is a very established tool. And here's my sketch of essentially what I already showed you, what my solution is. So I obviously have the Earth around the sun and the moon around Earth. And I created these animations. So this is the project I just showed you. And I just quickly wanted to go in there and just like in terms of the hierarchy. So I have one script on Earth. So let's say I just like, I nest them all. I do not nest them. So I just like place them like this. It doesn't change anything in terms of their position, but it does make a difference. So each of these have a rotation script, and I'll have them rotate very slowly, but I will rotate them a little faster now. Maybe let's do 3, and the sun, let's just do 1. So if I play it now, and I can show you the rotation script as well, but if I play it now you have all these planets like rotating by themselves, but nobody is actually rotating around anybody else. And so the trick to achieve this is just to work with nesting. So I nest the Earth inside the sun. Therefore, when the sun rotates, the Earth will also rotate. So just proof of concept, but I'll show you now. It flies around, and because the sun is going very quickly, I should now take a different camera position. So I'll just like make sure that my z-axis is probably further away. Oops, let me see, camera. Right. And that would actually be now really far away, like minus 100. So in AR, that would be 100 meters away. That's actually really far away. Right. So I can see a tiny, these are the dimensions roughly. I mean, this is what it would look like from somebody very far away. Tiny Earth and a moon around, which you can't even see. So anyway, I'm going to undo this because, okay, what I didn't do is actually, right, let's just leave it there. And so the last thing I do is I actually have I'll make this a little bit slower again, so it doesn't look so crazy. I'll just have the moon also go around the sun, and it's the same principle. I'll just nest the moon inside Earth. Sorry, I said sun just now. I mean, technically that's not completely wrong, but we want the moon to go around Earth, and then those two together go around the sun. Okay, and the rotation script is really nothing too special. Just opening it in Visual Studio. In fact, I think I found an example when you look for rotation in Unity. What I did is just like, so the rotate script takes whatever the current object is, the current game object, and I don't actually have to, actually I don't have to do anything here. I don't need the start one. I just did this one was like, I guess, just like a first example that would have rotated it by 60 degrees on start. But what I want is basically in the update function, which is called every frame, I want to rotate it a little bit, and I want to use the time, the delta time that is passed into, that I have access to in the update function, that allows me to, basically the time that has passed since I started this, this application, and that will be longer, obviously, the more frames have passed. And then if I multiply it by a certain speed, so for example, 1 or 2 or 3, it'll move faster. And if I want to have it rotate the other way around, I just use a -1. So it usually rotates this way. And so I wanted it to rotate that way. Okay, so that's the script, and then I just applied it to all the components. Then I made it a component for all these objects. I have sun, I have earth, which I guess was 1 or 1.2 or something, I forgot. And then the moon, I remember I did quite a bit faster, like so that it looks more visible. And this is now roughly what I had in the beginning. Anyway, so this is my 3D scene. We still haven't seen it in VR, so let's go into VR. Cool. So now comes the tricky part. So there are actually more videos. Actually, the whole solar system I created in 3 videos. I do a basic scene setup. I apply textures and materials that I got from NASA essentially, and this would be the part where you increase this is the third step in the assignment, where you increase the fidelity, maybe bring in a 3D model. So I could bring in this Luna module I found it before on SketchFab. So working with 3D models, I would often go for free models from SketchFab, for example. And I showed this in the last office hour. So the same stuff applies here. I would use an FBX, so that's important in Unity. I would work with FBX as the file format. GLTF is what I talked about in the last office hour. For web, the global transition format, GLTF is recommended, but for Unity, we would work with FBX. And then I don't actually have a 3D model in here. All these are basic 3D shapes with materials, and I initially color them, and then I replace it with textures. And you could even do some combinations of that. Anyway, and then I add lighting and change the background from the standard Unity background here to something more stars and sky using a 360 video. All right, so we're going to go into VR now. So once we are in VR, so the idea of the VR assignment is you'll continue from your 3D scene, and we'll need to add a kind of like an XR camera into the scene. So all these toolkits, and I show you the toolkits that I choose. So I'm solving this now with Unity, and I'm using Oculus integration package to connect to my Quest, and then Unreal Engine. I'm not using Unreal Engine, and then mixed reality toolkit for some of the interactions. It's just a setup that I recommend because I think it takes you very far, and I'll show you each of these components now, each of these toolkits. And then what you would do in the assignment is you first prepare your scene by adding a new camera rig. So this rig allows you to, in most toolkits, allows you to teleport and to take the controllers with you. Also shows the controllers when you have on the right, it shows the right controllers. So we show the white ones with the Quest, or the black ones with the Oculus Rift. And I will still need to decide which headset I'm gonna choose, because I guess they renamed Oculus Link or something. I just can't find it in the Quest anymore, but I'll still refer to things with the terminology. Meta is working very hard to get rid of everything that's called Oculus at the moment. But so really removing that as a brand, and so it's the Meta Quest now. It still says Oculus up here, but you can't see that, I guess. But that is confusing. So I just couldn't do the Oculus link just a second ago, but we'll try again. Otherwise, I'll switch to my Rift S. But I'll show you 2 different ways to deploy or run a VR scene. The most important thing is what makes it a VR scene is like adding the camera rig. And then once you have that in there, you can actually view the scene in VR, which means on the headset through the goggles. And then you would normally want to adapt the scene, like maybe scale it differently, maybe take a different camera position, maybe change the layout completely, because now the scale in the headset is very different from looking at it on a screen. And then the third step is to make it more immersive. So adding, for example, an environment, a terrain. I'll show you some examples there, lights, sounds, all that. And then add support for travel, which usually you get. The locomotion is usually supported with the toolkits that I recommended. So even just Oculus integration package has all the support already, but you could use, so I will use mixed reality toolkit. You could also use XR interaction toolkit, which is Unity native. I just don't like the look so much to it, but it does have examples of menus and teleportation. And actually, I wanted to find, I think I have a mixed reality toolkit here, but I also wanted to quickly show the XR interaction toolkit. So in the first week of the third course, we're going through all the different toolkits. And so Steam VR is obviously another way to do it, but here is XR interaction toolkit. So I'll just make that part of my slide deck here. Okay, it's like an office hour where you can watch me edit my slides. Cool. All right, so we're just going to place that roughly in the middle. I won't obsess too much about it, but this would be XR interaction toolkit. That's an alternative. They're not. You would use one or the other. This is an important slide. I want to show you. Did I finish the one before we would do object manipulation? So at the end of my little office hour, like in about 10 minutes, I guess, we would be able to interact with the objects. So Mixed Reality Toolkit is a toolkit that I've featured a few times throughout the MOOC. It's still under active development. It's done by Microsoft. It's really quite good. It was originating as Holo Toolkit. It was just for the HoloLens. And here I show example videos on HoloLens 2 rather than a Quest, but you can actually get things, you can actually get it to work. It has support for both VR and AR, including mobile AR as well. So if you're working on the AR assignments later, so next time in the office hour, I talk about a few different ways to solve the AR assignments in Unity. And one is using AR Foundation with Microsoft's Mixed Reality Toolkit, and then deploying to an AR Core, AR Kit enabled smartphone, or an iPad with AR Kit. But then I'll also briefly talk about how to deploy to a HoloLens. I don't expect that a lot of learners have access to a HoloLens. It's still $3,500, but sometimes people do. And obviously, I designed these courses for the majority, but I'm happy to answer questions. So this is my recommended setup for the VR assignment. You start from the 3D template. You could start from the VR template. I guess I was at some version in Unity, I was very specific about it, but right now, I would say 3D template still. You need to enable the XR plugin management. I show all that in a separate video. This process, setting this up, takes 30 minutes in itself. Use the Oculus XR plugin to actually get all the, to be able, so this gives me, with this, I then have, here's my MRTK project. When I have all that in there, I have, this then becomes options once I have the Oculus VR and the XR plugin in there. And so it's here under XR plugin management. That would normally be like enable it now, and then you enable it and it installs a bunch of packages into your tool. And then I can render to an Oculus headset right when I press start, or I can just render, I can just deploy it to Oculus, which would be going through the build settings, which I think I have here. It just opens this tab. And it's currently fetching connected devices, but probably the Quest is not on at the moment. But once it's on, it would like appear in there. I'll switch it on so it becomes an option. Right now it should be probably empty. And so once I have the Quest started, it was just charging. Once I have it started, it should become an option here as well. And that way I can deploy. But anyway, I shouldn't be tempted to try this now because I know this takes a long time and I've pre-recorded this. Let me see, now is my Oculus Quest here. It's connected. And I could actually pick this, build and run, and it would actually do it. I'll do it a third time then. So I'll build this in the background and try to get it running on the Quest while I talk to you. So, and then I also use the Oculus integration package. And MRTK, so Mixed Reality Toolkit, is the recommended toolkit that gives me all these hand interactions and menus and dialogues and widgets and 3D objects I can manipulate. So it's just a cool starting point. Also comes with various sample scenes. But I just use the MRTK Foundation package. It has Foundation examples, has like 5 packages. So all we need is Foundation for now. And then I have 2 ways to do it, to reach my quest. One is, well, you need to connect it via USB in order to deploy to it. Unless you're using other software like SideQuest, you can probably do a wireless upload somehow. But I usually just connect my Quest to the computer, and then it says enable data, which is currently happening right now. So, and let me see whether I can get SideQuest to work so you can see roughly what I'm seeing in my headset. While, oh yeah, while it's updating. Well, let's see whether this kind of like works. So, well, this led to some terrible rendering issues here on the headset now. I'm not sure what's happening. It looks like broken. Oh, I've never seen this before. Anyway, I'm just going to allow and hope it'll be fine after this. It just stopped the stream here, right? Okay. Let me just like, let's not break the headset now. It's already quite bad. Okay. So I would use SideQuest sometimes to just show to people what I see in the headset. So here right now, normally, just yesterday, when I was looking at this part, it would show up as Oculus Link. So I'm not sure what they just did. I have no idea where it is, but it used to be here. It used to be an option, and right now it's not showing up. And instead it shows me the Guardian only. And I have no idea actually how to enable it at the moment. This would be me. But if somebody knows and has this problem as well, it cannot fix it right now, I will just switch to my other headset. Because the only thing I could show right now is actually what I'm doing at the moment. It's actually deploying it. So I'm deploying it to my headset, which means it becomes like an application here as an unknown source. And then you can see some of the scenes that I have previously, which, oops, the stream stopped. Sorry about that. I don't know what's going on. I guess I should have not detected. Yeah. Anyway, this part was fun, right? I guess I don't want to update this. It's a really big red update button that really want to do. They really want to press it right now. Unauthorized, allow in headset. Okay, let's see. One more time. Okay, USB debugging, yes. Allow. Okay, it's currently not functioning the way I want it to function, so I'll do it. I'll switch to my other headset. 1 second. So me stopping this also means that I will not be able to successfully deploy it to my Quest headset right now, because I just disconnected it. What I'll show you instead is, so I have a video of that, but what I'll show you instead is actually using the Quest in combination with Oculus Link, which is really enabling this in the headset. It used to be called Oculus Link, and then the rendering happens actually on the computer. This is an option when you have a good computer. And it's the same as using a Rift S headset. So that's why I'm doing this. And okay, so the alternative to MRTK would have been XR Interaction Toolkit. You could use that, and you will find instructions on how to set it up, but they're on their website. It has teleportation, like what I show here. And it has various interactive behaviors, like grabbing objects. Like most of these toolkits have like standard support for grabbing, picking, sometimes snapping to the controller, like these are snap interactions, and different kinds of behaviors that you get for free. Then we also need the Oculus integration package. It was one of the things I showed here in my deployment slide, very important, Oculus integration package. We need that obviously if you develop for Oculus. If you develop for a different headset, then my instructions will not apply. But the Oculus integration package is just an asset that you get from the Unity asset store, which you then just add to your assets and import into your project. And I show all this in my 35-minute video, I guess, which is this one here. So this is the whole setup, and I go through all the different ways of deploying to a headset. And then one of the things is, once I have enabled Oculus integration, as if I anticipated this wouldn't work today, once I have enabled Oculus Link on the headset, I can actually use the headset once I press the play button, which is just like using a Rift. So I want to show very quickly 2 ways. So when you have everything set up the way I've set it up, when you launch it, you can say, yes, I want to run it on the Oculus, or you can disable this for a second. And because we're using Mixed Reality Toolkit, here's a standard scene with some interactive behaviors. I can now use a mouse and a keyboard to fly around in this scene. And then I can have hand interactions, which right now I guess is teleporting. But I can also grab objects with the right mouse here. So I have configured this in different ways. And I think I also have videos about how to actually configure all this for simulating interaction like here on a computer. But let's just like stop this scene, and I'll show you so this was just running it in a simulation on a computer. But then when I press Oculus here, I'm not deploying right now to my Quest 2. I'm just instead using my Rift S, my known and trusted Rift S, which is currently malfunctioning. I mean, what the hell is going on? Let me see. No, it is red. I will reconnect it one more time. I guess my side quest messed up something, but I'll close that now. Yes. And it just fell back to rendering on the computer. So one last attempt. So proud of my new computer. Everything was working fine. So, so this is the whole setup that I described in my video. How to create a new project, enable the XR plugin management and project settings. What you do for Quest specifically, you need to get all the Android stuff I showed initially, install Oculus integration package, MRTK Foundation package, just to have all that. And then if you wanted to deploy to your Quest, you would go through these extra steps of actually deploying and running on the device. You have to be an Oculus developer. There's something you have to set up in the app, in the Oculus app. So that's something you may have to Google a little bit because it's not straightforward always. And I don't know what kind of Facebook accounts you have, but so you need to become a developer in the app, and then you are able to deploy. And most of this is covered in my 35-minute video. And I just want to show, I guess, 2 more things. One thing that I think is part of the assignment is actually setting up a little bit of a terrain. So this is something that I think you'll have a lot of fun with in Unity. I have a video on that as well. So I'm opening my terrain project here. I'm gonna bring back the Unity hub for that. Wonder which one that is. Does it say this one is called Terrain Example and MRTK project? Okay, I have that one open already. So this is the standard interaction scene that I have, but I have a different one, which is this terrain here. And I am just gonna, let me see whether I can actually run it. It's still red, so I guess I have to restart my Oculus. Let me see. I can do that hopefully in the background. Restart Oculus. Okay. And I will just disable it here for, yeah, something is really wrong. I'll probably have to restart the computer. I'll show you what the problem is. So I would normally go here and do restart and would normally actually allow me to restart it. But and it's this red light here in the Quest is not good. And that just means that the tracking right now is not working. And it probably shows me an error message somewhere that I'm just like too nervous now because nothing is working that I don't see. But I'll just try, you know, doing the good computer scientist thing and just can't even close the app here. Anyway, so I'll show you the video instead, but and I run it here in simulation. So I created this terrain example. I guess there's cheese in there because a student asked me something about that. But you can just like walk around in this scene. And in VR, you would be able to teleport. It doesn't always work, I guess. Now the camera is below the terrain. That's unfortunate. Let me try this one more time. But I created this kind of like a beautiful-ish, I mean, for my standards, never mind the cheese there, scene where you have a little bit of a mountain in the background and a lot of trees. And so I show all this in my video as well, how I did that. So it is one of the steps in the assignment, ask you to create a nice environment. And so for that, this is actually then running it, I guess, on my VR headset. So let's just this is also simulation here, and I'm pretty sure this is now me in the headset. And I guess I had some problems sometimes with where I spawned, and I fixed it at the end of the video. I just moved the scene a little bit lower, and once the scene is a little bit lower, it actually makes a lot more sense walking around and navigating. So I'll just click through the last slides here. The video again that I also share with creating this terrain, which is like essentially one of the steps in the VR assignment. Together with deployment, you kind of like have everything that you need then. And the last thing is adding manipulation to objects. So in order to set up the terrain, you need to enable the preview packages. That is something you need to do in the package manager under project settings. That's also described in detail there. So please refer to that video. I just mentioned it very quickly here, but I think this is not the guide. I would refer to the video. Then you get the terrain tools, sample asset pack, and then I start like creating a terrain. The first thing I do is actually lower and raise it. So these are the tools here that I can actually use right now, even now. Just make this a little bit smaller. So if I wanted to create a new mountain or something, I would just go to the terrain tools, and this is paint trees. I already forgot it. That's crazy. Raise a lower terrain, and that way I can just like I can use a different brush here. So it comes with different kind of terrain style brushes, and then I click there, and the more I click, the more it raises it. And so you can create a mountain. Like this, probably where my starting point was. Probably not a good idea. I just destroyed it. You can see it on in the preview here. This is not actually where I want the mountain, but maybe I'll put a new mountain here in the background. You can see how it like looks from the camera starting point position. And then I actually should paint different textures on it as well to make it look like the other ones, make it look a little bit nicer. But anyway, so this is fun, and you'll probably spend some time painting textures and then adding trees, and I show all that in the video. And the last thing I wanted to show is actually adding manipulation. I just showed you the scene where you have like a cube in front of you that is very easily done with the object manipulator in the MRTK in the Mixed Reality Toolkit. And they have instructions for how to set it up. But basically, you would just add the object manipulator component to the object. And I'll just go back to my sample scene with a cube. That is what I did here with a cube. By the way, all the content in mixed reality should go under mixed reality scene content. Per default, people always put in the root, but that's not how it's supposed to be. And here's our cube. There we go. And then there I have the object manipulator, and it's a lot of stuff that I set up, but I also set up near interaction and far interaction, and this is still red. So, and this never restarted. But luckily we have kind of like a backup video. So I'll show you. Wow, 1 second. The manipulation stuff. So there is, I'll end my video, my office hour official part, which was supposed to end a long time ago with all the trouble. Here at the end is the Unity testing and deploy, and also setting up the cube and all that to actually run it on the headset, and then just go into full screen. And this is what should have happened. So when you do the Oculus Link, and then you have like the Rift S, like either the Oculus Link from the Quest 2 headset, like this one connected via USB, or the Rift S, it's the same thing. Then I can just run it in my editor, and I can just grab the object once I set up the Oculus. Once I set up the object manipulator, sorry, and also works with hand tracking on the Quest. So I actually wanted to show that, but unfortunately, let's see what questions we have. I'll just stop here sharing my screens and just wondering what kinds of questions learners have. And thanks for watching this so far and attending. All right. We can have a bit of interaction now. If you wanted to just ask in the chat or unmute yourself and tell me what you're wondering, we can do that now. Well, I'll still try to fix the headset, I guess. But I am here. No questions so far. In the chat, we have just a prompt for questions. What I'll do is I'll restart the computer here in the meantime, in case there's, I will still be here, so just the other guy who's leaving. All right, let me just see. No questions? Okay, so, well, these are then some of my tips. As I said, I was focusing mostly on the third course, the VR portion. There is additional materials that will link nicely into the MOOC. I think the office hour last time is just hidden somewhere in the MOOC. I'll rearrange it a little bit to make it a bit more prominent, and I'll also add new content to the MOOC so that you can find the YouTube playlist, the videos a little easier. And I just didn't have the time yet to do that, but we got the video is somewhere in the MOOC, the one from the first one. This one will also go in the MOOC. For the HTC Vive, do you recommend a toolkit? So that's a good question. So I have never really done a lot with the HTC Vive. I would probably use Steam VR. So I remember when we a few years ago, when I taught still in residentially, we have a really big computer room with like 22 headsets at Michigan. I mean, it's not so big, but it's kind of feels like big. 4 of them are HTC Vives. And so when we did that year, we used Steam VR. So Steam VR is probably the toolkit that I use. So every year that I've been teaching my courses, I've always used a different toolkit. First year was Steam VR, then I used XR Interaction Toolkit, and now I'm using Mixed Reality Toolkit for the last 2 years. But I would use Steam VR, and it is one of the toolkits that I go through in my course, Steam VR. The first video is in the week 1 discussion board. That's right. That's where where we put it, but we'll make it nice content as part of the honors track. And I'll write a little introduction to it, and we'll just make sure that learners can find it. I had trouble finding it, but it is in the MOOC. So Steam VR, yes, that would be my answer. And you can actually do, like, the setup is slightly differently, but it follows similar principles. I guess you would use a different kind of integration for the HTC Vive, so different kind of Unity assets. But it's the same idea. You get the packages, you set up the scene, and you make it, there must be some kind of plugin to deploy to the headset. Just like I chose Oculus there should be a different option than for HTC Vive. But I actually haven't done any active HTC Vive development on in a long time, and probably never have. I just know that we had a few students use it in class. It's a cool. I mean, I still have the Lighthouse. I mean, there's a Kinect and there's no Lighthouse there. Lighthouse is in the other corner. You can't see that right now. I have Lighthouse there and Lighthouse there, and I used to use the HTC Vive, but it's 5 years ago now, I think, 4 years. Thank you very much, Thomas. Yeah, so still happy to answer any questions. We have, I can stay like maybe 3-5 more minutes, and if there are any questions, I was mostly watching Michael struggle with his computer, and I swear I had everything ready and running, and it's just like did this to me again. Let me see whether my Oculus is. It's white now. Imagine it's a happy Oculus headset now. So while we are still recording, because I can't let you go this way. This is just like, this is unacceptable. I will, just so that it's not it's not another video with Michael's failing to get all this kind of like working in his office hours. What is he doing? So I will just make sure that I'll show, I'll be just live. I mean, it doesn't make a big difference because it's still video for you, but where does it actually go? Hang on 1 second. Yeah. I'll just come back into this course and just like run my little project here for 1 second while I can. Oh, we ran out of space, Unity says. Project folder or disk is read only. What? Never seen that before. So just checking. Are there any other questions? No. You're probably just waiting. All right, let me just make sure. I need to show you this. I've never seen this before. Please move the project folder somewhere else readable. I don't know what's going on. So I was just trying to open my MRTK project and it says it's already open. Cool. Here we go. Ta-da, finally. And so when I have everything set up properly, I should be able to click Oculus here. And I guess it would be SteamVR or something like that as one of these things. And then when I press play and actually run it in a headset, now comes the magic moment when everything launches. So I see the Oculus app launching on my computer, and it's now tracking my headset. And it's starting to render here as well. And I saw it for like 1 second, but then and I'll show you. So this is roughly what I see in my headset as well. And just need to find all the controllers here for a second. And it says the tracking is pretty bad at the moment. So, but here is the cube, and I'm just like wondering, can you see how I'm interacting with it? Okay, cool. And so now I have basic interactions like this object manipulator, so I can like rotate, I can scale it up, scale it down. And on my Quest, I can additionally just use my hands. I would have hand tracking, and I could grab the object. And obviously it would be super awesome if I could show that too now, but probably stretching it. I will just go one I just need to do this 1 second. Sorry, I cannot let it go. And this is why these assignments are so evil, because when they don't work, you feel like, oh my God, I really want to get this to work. And so I'm just still pretty angry that it didn't work before. So we're just doing this for me here, not necessarily for you anymore, but it is still being recorded. So I allow access. I'm now connecting a different, should use the white controllers, a different headset. We're definitely going a little bit over time here, based on what I have. Oh, now Oculus Link is a thing, and I can actually, so I have Oculus Link, which is USB cable to computer. It doesn't look very different for you because I still press play here, but it won't work now because I actually haven't enabled it. So I'll quickly just enable Oculus Link, which is an option here now. Yippee, finally came up. So launching on the headset, it's looking like a Rift S now, but you will see one difference. I can use my hands. And when I now start, when I now press play here, it's now actually my Quest. And you can see my hands. Can you see my hands? Yeah, you can see my hands. And now I can actually interact with this object just using hands. And that is, of course, something that you can only do with a Quest, but it is pretty cool. And I have near interaction, and I have far interaction, which is when these lasers come out of my hands. And these are things that I get kind of like for free, this kind of behavior with the object manipulator. And so I'm now a little happier, and I think I can let you go with this little demonstration. If there are no other questions, I would conclude the office hour here. There are no other questions. So basically, I'll release additional videos. We link it nicely into the course, and yeah, use the forums. Or yeah, and when you're done, what I really want to do, I want to thank all the learners that have completed the courses so far. It's quite a few. I really love reading your stories on LinkedIn. And when you add me on LinkedIn, I'll get to celebrate a little bit with you. So for those who have managed to graduate from the course, we will soon have first year of graduates, actually more than a year of graduates now. So maybe we can get them together and do something fun, chat at some point. Those of us who are currently still enrolled in some of the courses, hope you find them interesting, a little entertaining sometimes, and overall useful. And so good luck with all the assignments, and I hope you have nice interactions with the fellow learners. Check out the galleries that are linked throughout the courses. I was just browsing through them. So for example, in the second course, we have so many critiques of existing XR experiences, more than 120. So you will find lots of examples of other apps you can use to critique. And so I know that Google Expeditions currently is not an option, and I owe an update to the XR MOOC. But I just wanted to say that one more time here. So thanks everybody for coming, and I hope you have a great rest of your week. Bye-bye.